Hey guys, and welcome back to a new tutorial series. So essentially this is online game development with Python, which means we're going to be using sockets and networking to connect what's known as a client and a server, or multiple clients to a server where they can send and share information, and therefore we can create an online game. So we're going to start off with just the absolute basics and just get shapes. For example, like if I move a shape on my computer, it moves a shape on your computer, like if you're the other client. And then we'll start getting into some more advanced stuff where we create a legitimate game and start sending mass amounts of information to the server and back to the client. So we'll start really simply by just getting everything working on our local network. And then once it's working on our local network, we'll deploy that to an external server, which will allow us to play from anywhere in the world, not just against people on our local network. Okay, so what I'm showing you right now is actually an online game that I created with Python, Pygame, and networking. And this is similar to something we're going to make, obviously not as advanced, but it works on the same principles. So essentially, I have what is known as two clients. Now, if you don't know, the way that any online game works is we have multiple clients connecting to one main location, which is known as a server. Now, right here on my screen, we have two clients. So this client on the left that my mouse is kind of going over that has this red highlight, like where the rook is or where I just am about to move this knight, is client 1. And then this black one over here, so like you are black, where I just moved this pawn, is client 2. Now you can see in the background I have this command line thing going, and it's sending and receiving information. And this is essentially how a online game works. And you might see whenever you guys play an online game, it says waiting for server or connecting to server. And that's because it's doing exactly that. It's waiting to get a connection to the server and then grab information from that. So that's the way that we're going to be doing things, is using a client and server. Now, I'm not going to be using any frameworks that are pre-created, like I know there's like Twisted and some other frameworks for Python. The only module we're going to be using that's external is Pygame, and that's just to create some very basic graphics. Okay, so let's close this. I just want to give you guys an example of what an online game looks like, and you can see when I was moving something on one client, it would move it on the other. So let's close that up, and let's actually get started with the tutorial. Oh, did not mean to open that. So I'm going to be working with PyCharm for this tutorial. Now, if you don't know what PyCharm is, it's an IDE. To download it, all you have to do is just go to the internet, type PyCharm, and you can go here and click download whenever it loads up. Now, if you guys don't want to use PyCharm, that's absolutely fine. You can do everything using the standard editor like IDLE. You could use Atom. You can use whatever you want. But if you want to follow exactly with the tutorial, I'm going to be using PyCharm. Now, the next thing we're going to need, other than IDE, I guess you don't need PyCharm, is we're going to have to install Pygame. Now, for 90% of you, the way that you're going to be able to install Pygame is just by going to command prompt, loading it up like this, and just typing pip install Pygame, and then hitting enter. Now, if this doesn't work for you, I'll put a card in the top right-hand corner of the screen right now, which tells you where you can go to install Pygame. And I have a video explaining you exactly how to do this, and if this command doesn't work for you, you can follow that video, and I'll explain to you how to do that. So once we have Pygame, then we're ready to actually start writing a bit of code. So while I launch up PyCharm right here and create a new project, let me just tell you about, I don't know, some of the things we'll be going through in this tutorial series. So obviously we're going to be working on coding both a client and a server, and I'm going to explain obviously exactly how those things work and how we can create them. And then what we're going to be doing is we're going to be dealing with a bit of server like administration, if you want to say that. So actually deploying things to an external server, installing dependencies, working with like a Linux server to deploy our game to. And that'll be at the end of the series that we do that. Right now, we're just going to be working with what's known as localhost, which means that we're just going to be doing it on our own network. So right now, the games that we create are only going to work on our, against people that are on our Wi-Fi or on the same network as us. And then later, it'll work against anyone in the world that has that client downloaded. Okay, so let's just create a new project here. My new project, I'm just going to say, is tutorial, let's say network tutorial 1 or something. And just as a, here, just letting you guys know, I did actually mess up my thumb a little bit. It's kind of swollen. So if my typing is not the best, that is actually my excuse for that. So now that I've got a new project open, I'm just going to create a new Python file. Let's just call this tutorial 1. Actually, let's call this client, okay? And just save that as okay, because that's all we're going to be coding in this video. It's just a very basic client. Okay, so now we've got client. So what I'm going to start off by doing is creating a configuration for my client. And keep in mind, if you guys are using something else, you don't have to worry about what I'm doing with this PyCharm specifics. This is just the way you have to set up a project in PyCharm. So I'm just going to set a client. I'm going to go to script path, network game, client, okay, apply, okay. Now, quick side note, all of the code that I'm about to write is available on my website, techwithtim.net. Usually I have, as well as that, a text-based tutorial version. I'm not sure if I'm going to be able to write the text-based tutorial while this first tutorial is out, but you will see it on there at some point. Import tutorial, import Pygame. But yeah, all the code will be available in there in case you guys missed something or something's not working. So we're just going to start by importing Pygame and make sure that that's working. Once that's working, we're going to create a window. So to do that, we'll just say win equals Pygame dot display dot update, or what am I saying? Pygame dot display dot set underscore set underscore mode. Wow, a bit tired today, guys. And then in here, we're just going to type width and height, and then we're going to create these variables. So we'll say width equals 500, height equals 500, okay? So there we go, width, height, win, and now we're just going to set up a few global variables that we're going to have to use after we create a caption. So let's just say pygame.display.set underscore caption, and then here we'll just give it a caption. Let's just say client, okay? All right, so now let's set up a global variable that we're going to use, and what we're going to do for this global variable is it's going to hold the current client. So we're going to say client number, and we'll just start by making that 0, but we're going to increment that based on once we connect to the server, which we'll do later. Okay, so now that we've done that, there's a few basic things, and this is just what we always do for a Pygame project or whatnot. I'm just going to define redraw window, okay, and in here all we're going to do is just pygame.display.update like that, and we'll also fill the display before we do that. Oops, didn't mean to do that. With win.fill, and then we'll just pick a color. In this case, I want to do white, so we'll just do 255, 255, 255. Okay, now yeah, I just realized this is actually going to be a lot harder to type than I thought because of my thumb, so just excuse me guys if I'm making a few mistakes here. Okay, so we got our redraw window now, and what we can do next is we can code our main loop. So I'm going to say define main, and in here I'm just going to create a game loop, and this is going to run continuously while our program is going, and it's just going to be what's checking for collision, checking for events, constantly asking the server for information, and you guys will see how this works in later videos more. So we're going to say run equals true, and in here we'll say while run, and we'll just set up some very basic things that we always do for Pygame. So for event in pygame.event.get, okay, and then all we're going to do is say if event.type equals pygame.quit with all capitals, then we will simply do pygame.quit like that. Don't need a semicolon. I guess we can say run equals false as well. Okay, for events, that looks good. And then what else we'll do in here is we'll just call that redraw window function. So redraw window like that. Now, what I'm thinking we should do next is probably set up a class for our character, okay? Now, our character is going to be just the only object we're working with right now, and it's just going to represent a rectangle that moves left, down, up, right around our screen. And I guess we'll do that all in this video, moving that character around, and then we'll connect it to the server in the next one. So let's create a class, and we'll do that up here, and we'll say class player like that, okay? So we'll give it a init function, and if you guys don't know much about object-oriented programming and you want to learn, I do have a tutorial series on my channel that I would recommend you go through if you don't understand a lot of the stuff that I'm doing right now, okay? So xy with height will be what we get in here, and this is just going to represent, actually let's give it a color as well, because that'll be good to have, xy with height color. And yeah, this will just represent kind of our player and what variables they're going to have. So we'll pass these values in when we create a new player. So self.y equals y. This is very straightforward. Self.width equals width. And self.height equals height. And finally, self.color equals color. So these are just our initialization here. This is what we're going to use when we're drawing the character, when we're checking for collision or stuff like that. And what I'm also going to do to just save us a bit of time in the future is I'm going to say self.rect equals, and then in here, let's do this, okay? So x, y, width, height, like that, okay? And this will just make it a bit faster when we're trying to draw our character. So the next thing we're going to need is define draw. Now in the draw method here, we're going to take a window, so we'll call that win. And all we're going to do is just draw a rectangle that represents our character onto the screen, and it'll obviously be the appropriate color. So to do that, all we have to do is just say win dot, oh no, we don't have to do that. We have to do pygame dot draw dot rect, standing for rectangle. We have to first give the window, so we'll give win. We need the color, so we'll do self.color. And then we need a rect, which will be self.rect. Okay, and that's actually all we need to do to draw the rectangle to the screen. Now we need one more method we're going to use, and this is going to be called move. And move, actually, I believe, yeah, we don't need to do anything else in there right now as a argument, sorry. So for move, what this is going to do is it's essentially just going to check, if they press like left key, right key, whatnot, how can we move them around the screen? So the way that we can do this really basically essentially is just do pygame dot, dot keys dot get underscore pressed. I believe that's it. It might be key. Might be keys. We'll see. We'll see which one works. So this is essentially going to give us a list of all of the keys, actually a dictionary of all of the keys, and essentially each key is going to have a value of either 0 or 1. Now, if 1 is true, that means we're currently pressing the key. If 0 is there, then it means we're not pressing the key. So the way that this is useful as opposed to doing what we could sometimes do, which is just check for events in here, is if you're pressing more than one key at once, it'll allow you to move like diagonally or whatnot, okay? So what we can do in here now is we can just check if certain keys are pressed and then change the X and Y values accordingly. So we'll say if, oh, I guess we should probably put this in a variable list. We'll say keys equals pygame dot, maybe, I feel like it's key. We're gonna go key for right now. Pygame dot key dot get underscore press. So we'll say if keys and then pygame dot k underscore left, standing for our left arrow key. And that's all we need to do for that one. And then we'll say if keys and then pygame dot k underscore, should this be all capitals? I think it should be k underscore right. And then the next one, if keys pygame dot k underscore up, and then our last one obviously is down. And then we'll change our values accordingly inside of these if statements. So pygame dot k underscore down. Okay, so left, right, up, down. So if we press the left arrow key, obviously what we have to do is subtract from our x value. So to do that, we'll just say self.x minus equals self.vel. Now, vel is something we need to define, so let's do that up here. Self.vel equals, and let's do a value of like 3 for right now. Okay, so if we're going right, we need to add to our x, so we'll do this very similar. So self.x plus equals self.vel. Okay, if I could type that correctly. And then to go up, we're going to subtract from our y value. So self.y minus equals self.vel. And to go down, we'll do self.y plus equals self.vel. And that's the way the coordinate system works in Pygame. Our coordinate's actually at the top left hand of our player or our screen. So if we want to go down, we have to add to it. And then left and right is the same in terms of subtracting and adding. Okay, so that should successfully move our player. We could add like a jump and stuff in here as another time, but for right now, that's all we need. I'm trying to think of anything else that we could do right now. We should probably create a player object and draw that to the screen just to make sure everything's working. So to do that, let's create a player. Should we do it up here? Let's do it right above our main loop here, okay? So we're just gonna say, or actually we'll do it inside the main loop. This will work better. We'll say P, standing for player, just equals player, and then we'll give it some values. Need X, Y, width, height, color. So for X, Y, we'll just start them at like 50, 50, and then for our width, let's just do 100 by 100 so he's nice and big and we can see him. And then we'll do a color of green. So that would be red, green, blue, like that. So 255 for green. And then what we're gonna do actually is we're gonna type in here, insert in redraw window, we're just gonna pass P to our redraw window so that we can draw him. And before we do that, we'll call p.move, and what this will do is move our character based on what keys we're pressing. So inside redraw window, let's add a player, argument, attribute, whatever you want to call that. Parameter, that's the correct name. And then we'll just say player.draw, like that. And we'll pass win in here, which probably should be passed in here as well, because we do use win quite a bit. So let's do P, let's do win, and then P. Okay, so let's run this now and see if I made any mistakes. I likely did. process finished. Oh, we're never calling the main function. So let's call this main function from down here so that we're actually executing that code that we wrote. And there we go. So now we have a little green square, and you can see, interesting. It's not working for me to move this around. So let's check this one more time. p.move. What is move doing? Get pressed. Let's just add, I want to add something here and make sure this is working. So we're going to say clock equals pygame dot time dot clock. Okay. And then in here, we're just going to do clock dot tick. And we'll do 60 FPS. I just want to see if this is working. If not, I do know how to fix this. Okay, so we're not able to actually move this. Oh, I know why. So, very interesting. We are not updating this rect, but we are updating, what do you call it, like up, down, left, right. So at the bottom here, all we're going to do is just redefine our rect by doing self.x, self.y, self.width, and self.height. Now I'll really quickly explain why this error was happening. Essentially, we're defining rect up here based on the input parameters when we're creating our player. So that means we're always just constantly drawing our rectangle in the same position because we're never updating this rect variable. We're only updating like x, y, width, height, right? So we just have to redefine our rect variable every single time that we're moving, which is fine, and we can do that. So now let's see, and we can move our green square around the screen. I actually quite like the speed of this movement. So yeah, so essentially in the next video, what we're going to be doing, so I'm wrapping it up here, is we'll add a little bit more to this client, and then we'll start working with sockets so we can connect this up to a server, and we'll start talking about all the networking aspecting then. So in this tutorial, we're going to be working on coding the server, and then in the next video, we're going to be connecting this client that we made in the last one to that server, and then sending information to and from the server. So let's get started, and let's create a new file that is going to be our server file. So I'll just call this one server.py. And then in here, we're just going to have to import a few things, and I'll talk about exactly what they're going to do for us once we start using them. So let's start by importing sockets, or socket. Then we can import underscore thread, and we'll also import OS. Okay, so actually not OS, sorry, SYS. That's all we need for that. So what we're going to be doing, like I've talked about, is we're going to be using sockets and threading to handle connections to our server. And essentially what that means is we're going to set up a socket, and it's going to allow for connections to come into our server on a certain port. So we're going to start by just defining a server, which is going to be a string, and port, which is going to be a number. Now for ports, you guys probably know what ports are. You might have heard of them before. For example, like a common port you would use on, or a common port that is used like on your router would be port 80, and that is for HTTP connections. There's also a port like 443. There's tons of other ports that have distinct uses. But there's also a ton of ports that don't have any uses and that are just left open for programs like this or for different things to be used for. So what port I'm going to use, which is typically open, it depends on like what router you're using and your internet connection, but typically a port that's open is 5555. So we're going to use this port to connect to and from, and it's just a safe port to use as opposed to trying to use another number that we might not know if it's being used for something else or not. Okay, so once we've done that, we've created a server and created a port. What we're going to do is we're going to set up what's known as a socket, okay? And we'll talk about exactly how this works in a second, but we're just going to say s equals socket dot socket, and then here we're going to type something that's probably going to mean nothing to you, but I'll talk about what it means. So we'll say socket equals af underscore inet, okay? And then socket dot sock stream, like that, all right? Now these are just the types of connection. So since we're going to be connecting to a IPv4 address, which again, we're going to keep talking about all this stuff as we go through in case you guys are unfamiliar with networks, this is the type we're going to have to use. And sock stream just, I believe, represents like how this server string comes in. I could be wrong on that, but this is the type we're going to use. And for any kind of applications like this, this will be what you use for your socket. Okay, so we're just initializing that. And now the next thing to do is to bind our server and our port to the socket. So to do this, we need to do a try and accept. And the reason we do this is because, like I talked about, we don't know if this is actually going to work initially doing it. There could be, in some instance, this port is already being used for something, and if that's happening, that means that this is going to fail. So we need to try and accept this. So we'll accept, what do you call it? Error as E. So what do we say? Socket dot error as E, and we'll just print that out to the screen just so we know why we're not working there. Otherwise, what we'll do is we'll say s.bind, and then in here we're going to put server, comma, port, okay? So we'll bind to whatever IP address we'll put in here to this given port. Okay, so I hope everything's making sense so far. Essentially what we're doing when we do sockets is we're setting up a connection, or we're using a port on our server, on our network. It's going to look for certain connections. And then we'll be doing this on the client side as well. We'll be binding, or not, I don't know if we'll be binding. We'll just be connecting to a certain server and a port. And then since we're connecting to that, this server script that we're going to have running will see that connection and handle it in some way. Okay, so now that we've done that, I'm trying to think what else we have to do. Okay, so what we're going to start by doing is we're going to start listening for connections. So we're going to do s.listen. Now, s.listen essentially just opens up the port, so now we can start connecting to it and having multiple clients connecting and whatnot. So in here, this actually takes one argument. Now, it's optional, and if you leave it blank, it means it'll allow for unlimited connections to happen. Now, depending on what kind of program you're writing, is what you're going to do for this. Now, for me, I only want 2 people to be able to connect to my, to my server. So we're just going to do s.listen 2. Now, this might actually be 1, because it might be like 0, 1, but I think 2 may be the correct thing. So we'll do s.listen for now. And then what we're going to do is we're going to print after we listen. We'll just say waiting for connection, and we'll say server started or something like that. Because once we get to this point, we are running the server and everything actually is working. Like, we're listening for connection, we're ready to go. Okay, so the next thing we're going to do is we're going to define something known as a threaded function, okay? And I'll talk about again what this means. But let's just do threaded underscore client for now. And I'm just putting, you don't actually have to name it this, you can name it whatever you want. I'm just putting threaded here just so we know this is threaded. And then it's going to take one argument, which is just going to be conn, which stands for connection, and let's just pass in there for right now. So the way that threading works, actually let's do the threading and then I'll talk about how it works, because it'll probably make a bit more sense. So let's do a while true down here. Okay, so once we set up our server, our port, we bind it, doing here, we're starting to listen, waiting for a connection, starting the server. Then what we're going to do is we'll be put into this while loop. And what this while loop will do is we'll continuously look for connections, okay? Because right here, we're just listening like once, right, to see if anything's on that server or port. But down here, we want to continually try to grab connection to see if something's connected, and if it does, then we want to print something to the screen, or we want to send information, or we want to start a new thread, which we'll talk about in a second. So in here, what we're going to do is we're going to say connection, which is conn, and then adr equals, and then s dot, and then we'll say accept. And what s.accept is going to do is it's going to, well, accept any incoming connections. And then it's going to store the connection and the address. And the connection is, by the way, an object representing like what's connected. The address is going to be an IP address in these variables, okay? So if we get a connection, what we'll do is we'll say print connected to, okay, and then ATR. And this is just going to show us what IP address is actually connecting, so we can have a look at that. And then what we're going to do is we're going to do start underscore new underscore thread. And then in here, we're going to do, what was that name of the function that we had? Was threaded client. Okay. And I believe we do comma, and then in brackets here, we do con like that. Okay. So start new thread. Is there a reason that's not working? Give me a sec, guys. I want to see why. Oh, that's why. So up here, instead of saying import thread, we're going to say from underscore thread import star. Okay, and that's just going to make it so we can just do this start new thread thing. And you know what? I don't know if we're going to need this sys, but let's just leave it there for now. Okay, so let's talk about what threading is going to do. So essentially, the way that you guys are used to programs working, I'm assuming, unless you have some familiarity with threading, is that say we're in this while loop, right? And we were to call the function threaded client. Well, before we continue going with this while loop, we would have to wait until this function was done running. In other words, we return back from this function some value, or for example, like it does like x equals 5, we would have to wait for this x equals 5 to execute, and then it would come back in this while loop and keep going. Now, we don't want that to happen because we're going to be having multiple connections going at once. So what we want to do is we want to start what's called a thread. And a thread is just another process that's running in the background. So that just means when we do start new thread and we do threaded client, it's going to run this function, but it's not going to need this function to finish executing before it continues the while loop. So this is going to be running in the background as like process 2, while process 1 is still running and still going. So that means, say we connect to 100 different things. We're going to have 100 different functions running, so 100 different threaded clients on the stack, or like keep going. And then what we're going to have is this while loop still continuing to go. What did I just do? Still continuing to run to look for another possible connection. You guys will see more how this works, but essentially just means this will run in the background and we don't have to wait for it to finish executing before we can accept another connection. That's the basic kind of way that works. So now let's start working with threaded client, and then we will test the server out and see if it's working. And then obviously in the next video, we're going to connect to it and do all the connection stuff. Okay. So in here, threaded client. So what should happen when we connect to a client? Well, we're going to have to do a while loop in here. So we're going to say while true, because we want this to continually run while our client is still connected. Okay. Now, what we're also going to do is we're just going to say reply equals blank like that. And I'm just copying from my other screen because this one is a bit finicky. I don't want to mess it up. We're going to put a try in here. And what we're going to say is we're going to try to receive some kind of data from our connection. Okay. From whoever's connected, we want to receive some kind of data. So what we'll do is we'll say, I believe it's scon.receive. That might be right. Yeah, I think that's right. And then in here, we're going to put the amount of bits. Okay. Now, if you guys know anything about computing, you know like what bits represents, but essentially this is the amount of information we're trying to receive. Now, if you're getting an error when, say, you like do this and you connect up and you get some error that says, what do you call it? Like object was truanced, or like you're getting any errors, just increase this size, okay? And you can just do that by like putting this like times 8 or something. Just note that the larger this size is, the longer it's going to take to receive information. And that's obviously because the more information you're getting, the longer it takes to send that over the server. So 2048 bits is not a lot. It doesn't take very long. It happens almost instantly. But if you bump this number up to a ton, then it will take longer to do that, okay? So data, and we're going to say reply equals, and then we're going to say data dot, I think it's actually string dot decode. Let's see this. Oh, data dot decode, because it'll be in that kind of object. Remember that, data dot decode, and then here we're going to do UTF, comma 8. Now the reason we have to do this is because whenever we're sending information over a like client server system, we have to encode the information, and you'll see that in the next step that we're going to encode information before we send it back to the client. But that means that we're receiving encoded information. So to actually be able to read it, like in a human readable string, we need to decode it first. So it's really easy to do that. We just do .decode, and we're just giving the format, which is UTF-8, okay? So reply equals that. And then what we're going to say is we're going to say if not data, we're going to print disconnected, okay? And then we're going to break. And this just means if we try to get some information from the the client, but we're not getting anything, we're going to disconnect and we're going to break. And that likely means that we've disconnected from the client, or the client's left, or something like that. So instead of continuing to run this while loop and trying to get information from a client that's disconnected, we're going to break. This is just kind of a fail-safe to make sure we don't get into any infinite loops. And it's also going to show us if we're running into any issues with like receiving the data and decoding it, which we'll talk about later. Okay, so otherwise, so if we are getting information, all we're going to do is we're going to print received. Is that how you spell received? Maybe. And then we're going to put, reply. Okay, didn't mean to do that. Let me see if I'm spelling this right. I am not. Okay, received reply. So this just means we received from the client this reply. Let's print it to the screen, see what it looks like. And then we're going to print sending colon, and we'll just print reply, okay? And then we'll talk about this again in a second. Why does this keep happening? Okay, reply. Next. Now, after this if not data breakout, what we'll do down here is we're going to say con.sendAll, and we're going to send str.encode reply. Now again, remember that since we're sending information over the server, we have to encode our information. So all this is going to do is just encode our string reply into a bytes object. So that means when we read it in from the client side, again, we'll have to decode that information. It's kind of annoying, but I mean, it's a security thing, right? So now we're just going to accept, I guess, what kind of error would it even be? I don't even know if there's going to be any errors. If we run into anything, let's just break, just to make sure that we're not, getting in that infinite loop, or we're not going to ruin the program by doing that. Okay, so this is actually about it for our server. Let's see how much time we're at. 13 minutes. Okay. So now what we need to do is figure out what this server number is, and then we can actually test it and see if this is working. So what we're going to do now is we're going to find the server number. Now to do this, we're going to be doing this over localhost, okay? That means that we're only going to be able to connect over our local network, meaning that like anything on our Wi-Fi network that can see each other, that'll work fine. But as soon as we go outside that network, it won't work. So we're going to be using what's known as local IP addresses. So to find the local IP address of the machine you're currently on, you're going to go to command prompt in the bottom left. And then you're just going to type ipconfig, okay? Now, some of you guys are probably freaking out because you can see my IP address right now. This is a local IP address, and that means that it is locally assigned to my network. No one outside of my network can see this IP address or can ping it or can DDoS it or anything like that, okay? So it's perfectly fine if you guys see this address or if other people know what this local address is, okay? Just as a note. So what we're going to do is we're going to take this IPv4 address, so I'll just copy that, and we're going to paste that inside of the string here, okay? So 10.11.250.207 is mine. Now yours likely is like 192.168. something, okay? But since I'm on like a massive network, usually they use 10.10 like as the default gateway, which is what they're using. So my IP address starts with a 10. Yours likely starts with 192.168.1. or .5 or something like that, and then the rest of it, okay? So that's the address we're going to use, and this is going to be our server address. So whatever machine that you're going to be running this server script on, that's the address you want. So say you want to run this server on your laptop, and you want to run clients on like your PC and your Mac or something like that, then you want to make sure you get the IP address from your laptop and you're putting it in that script, okay? And we'll talk about more of this in the next video when we actually connect to it. Okay, so now that we've done this, I probably made a mistake, but let's actually just create a configuration quickly for server and run this and just see if we're getting any errors as of now. Now, it is worth noting that we're not going to be able to connect to anything yet, so there's not really going to be much we can see or really do, but for now, let's just test this out. So let's have server, let's run this, and you can see waiting for a connection, server started. So that's actually good. If you're getting this string of text, everything is currently working. In the next video, we'll probably have to debug a little bit once we start connecting to this, but for now, that is the main server script. Now, I'll briefly just talk about, before I end this video, how it's going to work in terms of running the server script and running the client script. The server script always has to be running, okay? So whenever you're trying to connect, you have to have first run the server script, and then you can run multiple client scripts from wherever on the network you want. Now the server script has to be running on the machine that the IP address is like this little string here, okay? It has to be running on that machine. And you can run a client script on the same machine that the server script's running. And you can run multiple client scripts on the same machine. So like, for example, what I'm going to do to test this in the next video is I'm going to run the server and then I'm going to run 2 clients on this machine, and we'll see that it like is moving back and forth for them. So what we're going to be doing in this video is we're going to be coding the kind of client side of this, so connecting to the server. I know we already coded a client, but we're going to code like the network aspect of the client so that it can connect to the server. It's not as much code, it's a bit more straightforward. And then we're just going to test out sending very basic information to the server and hopefully getting some back, see if that's working okay. And then in the next video, we're going to be connecting this. So like the little user interface we created with moving that block around in the first video, we're going to be connecting that so that we can have multiple clients running and we can see like different blocks moving on each screen, okay? So that will involve a bit more work. Hopefully by video 5, we'll have like a fully working kind of game that's working over the network, okay? That's the goal. So within this video, I just want to start by saying on this server class here, or sorry, server file, I did actually forget 2 lines of code in the last video. So after this accept break in threaded client, just need to add this print lost connection and then connection.close. All this is doing is once we break out of this threaded client, we're just letting the, we're just going to print this to the console so we can see what it looks like. and then we're going to close that connection so that we can possibly reopen it in the future, okay? Really straightforward. That's all you got to add, so just make sure you add that before moving on. Okay, so next what we're going to do is we're going to create a new file, and I'm going to call this network, okay? Now you don't have to put what I'm going to in a new file. It's just a lot easier, so that's why I'm going to do that. So let's do network, and in here we're going to import socket. Now what I'm going to do is I'm just going to code a class that is going to be responsible for connecting to our server. And this just makes it like so I can reuse this class in the future, and you guys could reuse this class in the future, and it's just a bit cleaner and nicer, and that's the way I like to do things. So we're going to say class network. Again, call this whatever you want. And in here, we're just going to set an initialization function. We'll take actually as network. Do we need anything in network? No, I think we'll just leave it like that. So we're going to say self.client equals socket.socket. It's going to be the exact same arguments as last time. So we'll say socket.ifnet. I think is that what it is? if underscore net. af underscore inet. Okay, and then we'll do socket.sock stream like that. Okay, now we're going to define the server and the port again. So self.server equals self.port equals 5555. Now for the server, this number has to be the same as the one you used in the server, the server file here. So no matter what, like no matter where you actually are, like what client you're using, this number is going to stay the same because this is the server you're connecting to. It's not the client's address. We don't actually have to define the client's address anywhere. It'll automatically get that for us. Okay, so what we're going to do now, we have client, server, port. We need to do this, self.addr equals, and then we're going to say server, so self.server, and then self.port in here, okay, and then self.id is going to be equal to self.connect, okay. Now you guys, actually let's just do self.connect for right now, and we'll talk about why I was going to add this ID later once we add that functionality to the server, okay. Essentially I wanted to have an ID that was returned here, or like that was stored in this network object, just because we are going to have to like be sending an ID to each of our clients so they know if they're like player 1 or player 2, but we'll do that later because we can't really do that yet. Okay, so we've called this connect method, so we need to write that now. So let's say define connect. Okay, and in here I believe we should probably be given, actually it's probably fine to just use self right now. And what we can do is we can do self.client.connect, okay, and then in here we can do self.addr. Now we're going to throw this in a try and accept, just in case, you know, this isn't working. So we'll say try, we'll say accept, and are we going to do socket error? Let's say accept, and we'll just pass right there, okay, just in case this doesn't work. So we'll try this, we'll try to connect, accept, pass. Now, once we actually connect, what we're going to do is we're going to return, I'm just looking at my other screen right now, self.client.receive, and then we'll do 2048.decode. Okay, so what this is going to do, I'll talk about this because it might be a little bit confusing, is when we connect, we want to actually send some kind of information immediately back to the object that connected to us. So like, for example, let's go in this, I didn't mean to close that. Let's go into server here. And you can see when we initially connect, we're not sending any information until we receive something. Now that's fine, but when we connect, we should really send some kind of like validation token or like ID back to our network object or back to our client. So what I'm going to do in here, I'm going to say con.send, okay? And then in here, what we're going to type is, let's see, what should we really type here? str.encode. And then here we'll just say connected like that, okay? Just so we know that we did indeed connect. So that means if we set this equal to a value, so self dot, I don't know, let's say ID equals self.connect, what'll happen is when we connect, we'll return that string connected. So this will get connected. And since it's encoded, we need to decode it, obviously. So if we want to print actually in here, self.id, it should say like connected, okay? Let's see if that works. Okay, so now that we actually have that, let's see if we can connect to the server, and then we'll deal with sending information from the client to the server as opposed to just getting it from the server, okay? I know it's a bit confusing right now. I'm just trying to figure out the best way to do this. So let's try this, okay? So we're going to say n equals network, We'll just type this in the bottom of the script. We won't do this after. We'll delete this just for testing purposes. And then we're just going to say, actually, that's probably all we need to do because it'll just print our ID. Okay, so let's create a configuration for network. So new configuration, type network in here, and then select that path. And then let's test if this is working. So remember what I said, when we're going to connect right to our server, what we have to do is first run that server script. So let's run the server script here, waiting for connection server started. Okay, let's run this network script now. Invalid argument was supplied, s.listen to. Okay, so I had a quick look here. I realized the mistake was I was actually running this server 2 times, so obviously that's not going to work for us. So we can put 2 back in this listen. I'm not sure if you guys, we'll see if I left that in the video or not. But let's go to network, and we also need to change this to AF instead of IF. I don't know why I typed IF. I literally said AF when I was typing it, but that's fine. And we have server. I'm actually running it right now, so make sure you guys run that, and then let's run network and see if this works. Okay, sweet. So I know it doesn't seem like much, but you can check here. If we go to server, it says connected to, and then gives us that address. And it's also printing out some other thing that I honestly don't know what that means. And then it's saying disconnected and lost connection. Sweet, that's actually really good, and that means that everything is working. And you can also see that we have connected being printed here. So that means when we connect to the server, we're actually getting the value that it's sending. So we're getting this connected, and we're printing it out, decoding it all fine. So that's really awesome. So now the only next step is to actually send information to the server and keep like a loop going, like sending, receiving, sending, receiving, sending, receiving. Now let's actually just test. If I run this again, you can see again, obviously it's working again. So this is the server just continually is running. I don't actually have to stop this unless I want to make modifications to it. So let's just keep that running for now. And let's add something to our network class. So in our network class, we're going to define a method that's going to be send. Now this method is going to be very useful later on because it's going to save us a lot of time. So in send, we're just going to take a string, which is going to be data, okay? And all we're going to do in here is we're going to try to self.client.send, and then we're going to say data str actually .encode data. And then we're going to get a reply from that server, so we're going to say return, so exact same thing that we're doing here. Self.client.receive 2048.decode, and we'll accept, and I believe this is a socket error. Yeah, it is socket.error as E, and just print E. So if we get into some error where, you know, either we're sending or we're receiving and it's not working, let's just print that error out to the screen so we have a look at what that really means. So now let's do a test and try to send information to the server and then get something back, okay? Now, the information that we're getting back should just be the same information because that's what we have in server. We're just going to send exactly what we got right back, right? So it doesn't really make sense right now to do that, but we'll talk about like what valid information we can send, how to send, receive information in the next video when we connect up the client to the thing, okay? So what we're going to do is we're going to say n.send, and we'll print n.send, okay? And we'll print n.send again, and let's just send like a few bits of information and see if everything is indeed working. Okay, so n.send, and then in here, let's just type hello, and we'll type working, okay? And see if this works. So we should have, yes, server is working. Well, let's run our client, and you can see we get connected, hello, working. And if we come here, it says received hello, sending hello, received working, sending working. So that's awesome. That means our network class is working, sending information, receiving information is working, server is working. And now the only thing that's left to do essentially is to connect that up to this. So use this network class in some meaningful way here, and then to actually store information on the server and then send that information to multiple clients, which we'll be doing in future videos. What we're going to be doing is we're going to be hooking up our graphical client to our server so that we can send information back and forth. And ideally at the end of this video, what we're going to have is we're going to have 2 rectangles on each client. So we'll have like 2 clients running. And when you move the rectangle on one client, it moves on the other and vice versa, okay? So you guys will get the idea when we go through, but there's a little bit of work we have to do, and we're going to be modifying a few things within a lot of the files we've already created, so just make sure you guys are paying attention. And again, if anything is going wrong, feel free to download all of the code off of techwithtim.net. It'll be available there, and it'll be exactly the same code that I'm writing right now, okay? So first thing we're going to do is in this network class, we're just going to delete a few things. So this testing stuff, we don't need anymore. This print statement for the self.id, we don't need that. And we're actually going to change this self.id to be self.pause, okay? And you guys will see why we're doing that in a second. And we're going to add one quick method in here, and we're just going to say define get pause, okay? And all we're going to do here is just return self.pause. All right, and again, you'll see why we're doing that, but I just don't want to have to come back to this network class, so we'll do that for right now. Okay, so from inside our client now, what we're going to do is we're going to import this network class because we're going to use it in here. So we're going to say from network import network, and then in our main function down here, what we're going to do is actually above player, we're going to say n equals network, okay, like that. And then what we're going to do is we're going to say start pause equals n.getPause. So essentially why I'm doing this is because when we first connect to our server, what I want to happen is I want it to return to each of our clients the starting position of their character, right? Or of their cube, okay? Because it's going to depend where they're starting based on if they're player 1 or if they're player 2. So then on the client side, what we're going to do is when we initially connect to the server, which is what we're doing when we create this network object, we're connecting to the server. We're going to get that starting position, and then for creating our own player, we're going to use that starting position to determine like where we're starting. So the position is going to come in as a tuple, all right? And we'll be coding all this on the server side in a second, but it's easier just to go through each file rather than going back and forth. It's going to come through as a tuple that looks something like this. So it'll be like 50, 100, okay? So what we're going to do is you're going to read this tuple in because it's actually going to come in as a string. Like you'll see how it comes in. We're going to get the two aspects of it, so like the x value and the y value, and then we're going to use that inside of this player initialization to like set the initial position. So that reminds me, what we're going to be doing when we're sending information to the server is we're going to send it using string data, right? And that's what we were doing in the last video, is we were sending everything with strings. So we were sending like hello, and then we were decoding it and encoding it. Now, this is not the only way we can send information. We can actually send information with objects, and I'm going to show you the advantage of doing that in the next video, but for now we're just going to send strings. So since we're going to be sending strings, the strings that I want to send are positions, okay? I want to, from each client, send the current client's position to the server. The server is going to get that position, update it on the server side, and then send the other client's position back to the client. You guys will see how it works in a second. Actually, let's see if I can do a quick drawing to illustrate this because it'll make things a bit easier. Okay, let's, I don't know why I had this. Let's delete that. Okay, so let's do a quick drawing. So what we're going to have is we're going to have client 1, and excuse me because I'm drawing this with a mouse, and client 2. Okay, so this is going to be 1, and this is going to be 2. All right, this, we'll do it as a red box, is going to be our server. And on the server, what we're going to do is we're going to store positions. So we'll say like 1 has position like 1, 2, okay? Sorry, this is hard with the mouse, guys. And then client 2 will have position like 3 and 1, okay? So it's going to store these positions. So what's going to happen is when we initially connect, client 1 is going to go to the server, it's going to connect to it, and then it's going to be sent back the starting position for the client, okay? So it's going to be said, okay, so you're client 1, so that means you're going to start at position 1, 2. Client 2, it's going to connect. It's going to say, okay, we're client 2, so I need to send client 2's position, so let's send that back, all right? Now, let's say we've already connected, client 1's there, client 2's there, and we've set their starting positions. What we're going to do next is now we're going to continually call to the client and update the position. So what we're going to do is say, say we're working with client 1, okay? What it's going to do is it's going to send its position to the server. So it's going to say, let's just say pause, okay? It's sending its current position. Let's say that position is like 4, 5. Sorry, this is really hard with the mouse. Okay, 4, 5. What's going to happen here is we're going to say, okay, so you're updating your position. So then it's going to go in here. It's going to say, okay, client 1 will update your position to be 4, 5, like that, okay? And then what it's going to do is instead of sending back this same position, because we already know what the position is, it's going to send back the position of client 2. So it's going to send 3, 1, and then on here we can draw that client so that it looks like it's moving, right? So we're sending our information, and then in return we're receiving the other client's information. Now the same thing works here with client 2. So if client 2 connects, right, and it's sending information, it's going to send its position. Let's say it sends the position 1, 3, okay? That's its updated position. So this is going to change to be 1 and 3. And then what's going to happen is it's going to say, okay, well, we don't need client 2's position. We need client 1. So what's client 1 position? Well, that is 4, 5. So let's send 4, 5 over to client 2, and then on client 2 we can draw 4, 5. So you'll see they'll simultaneously be moving. I hope that makes sense. I just want to draw it out for you so you guys know what I'm about to do in this video. Okay, perfect. Now the only thing is we need to send these positions as strings. So we're actually going to have to implement 2 helper methods so that we can convert those positions, which are going to be tuples, into strings, and then we can also read the string into a tuple. So what we're going to do is we're going to say define, and I want to remember what I called this one. We'll say this one is read underscore position, which means we're going to take a string value and we're just going to read the string in. So we'll say str equals str.split, and we'll split it at a comma. Okay, and you guys will see how this works in a second. And then what we're going to do is we're simply going to return the int of string 0, so str0, okay, comma int of str1. So what we're going to do is we're going to take a string in that looks something like this. It'll be like 45, 67, okay, in string value 45, 67. We're going to split it, which means we're going to get a list that has the string 45 and the string 67, and then we're just going to convert those to ints and return them as a tuple. So now we get that converted to something that looks like this, which is useful information that we can actually use, okay? So that's what read pause is going to do, but we need to make one more, which is going to convert that position into a string. So we're going to say make underscore position. And in here, what we're going to have is we're going to take a tuple. So we'll just say tup, standing for tuple. And what we'll do here is we'll say, let's see here, return tup, actually str of tup0. And then we're going to add that comma in. So sorry, I'm butchering my typing right now. Comma plus str of tup1. And I hope that makes sense how we do that. So that's returning the string value. So we're reading pause and making pause, and that's all we need to do for those helper functions. Okay, so that means though that when we get the position initially from our server, it's going to come in that string value, right? It's going to look like 45, 67. So we need to convert that. So what we'll do is we'll say read pause. And we'll just put that around n.getPause because it's going to return to us that string position, so we'll read it in. And now what we're going to do is for our player, we're going to say start pause 0 and start pause 1, okay? And what this is going to do is just set it to the initial start position. We're going to code all the server stuff after. It'll start making a lot more sense, okay? Now what we also need to do is we need to create a second player because we're going to have to draw the first player and the second player on the screen, right? So we're going to say p2 equals, and we're literally just going to copy this, except for start position, we're just going to put it as 0, 0 for right now, and we'll update that in a second, okay? So we have p2, and for now, that's what we'll do. Actually, we can continue working in here so that we don't have to do anything else in here after. We'll just code the server side. So what we'll do now is we're going to send our current position to the server, right? That's like the algorithm we've developed. Essentially, when we connect, we're going to get the starting position. We're going to set that starting position. And then every time after that, so like every time the frame updates, we're going to send our position and then get the other person's position. So what we're going to say p2 pause is going to be equal to n.send, okay? And we're going to send make position of, and then what we're going to have to do in here is it's a little sketchy, but we're going to do p.x, p.y. Now, right, because that's the position of our player, the x and the y coordinate, we're putting it in tuple form. We're sending it to the function make position, which is going to turn it into a string, and then we're sending it to the server, right? Okay, awesome. So I think that makes sense. And then what we're going to do simply is for p2, we're going to update its position. So we'll say p2.x is going to be equal to, actually, n2.send, but what we're going to have to put around here, sorry, is make pause, read pause, because, right, it's coming in as a string, so we need to convert this into our actual position. So p2 pause is going to be p2 position 0, and then p2.y is going to be equal to p2 pause 1, okay? Now, the only thing that's left to do here is, draw P2 and update P2's rectangle. So what we're going to do now is in the redraw window down here, we're going to put P2. We're going to go to redraw window. We're going to say player 2 here. And then we're going to do player2.draw window, because again, it's going to be a player object, so that'll be fine. And then last thing to do is just update the rectangle. So what I'm going to do is I'm going to say P2.update. And we're going to go to player object now. We're just going to add this one function that is define update, and then So you see, I just made like self.rect equals x, y with height. And then in here, I'm just going to say self.update like this. Okay. So I know these might be getting a bit confusing, but we're almost finished. I just got to do the server side, and then we'll recap through everything, what we've done, explain things. I just kind of have to get this content out. Okay, so define update. So what we're doing again here is before we just had this line of code here. So we're just replacing that with an update method. That's pretty straightforward. I hope that makes sense to you guys. And that's just, again, so when we change the x and we change the y value of p2 directly, then we are updating the rectangle so when we draw it to the screen, it's in the correct position. Okay, so I believe that's all I have to do for the client side. So now it's time to go to the server side, and the server side is pretty straightforward. Now, the server needs to keep track of the positions, right? It needs to hold player 1's position and player 2's position consistently. So we can decide if we wanted to store that, let's say, like on a hard drive, or if we wanted to store that in memory. Now, in our case, it's not a lot of information, so we're just going to store it in the memory of the server, right? So what we'll do for that is we're going to create a list, and we're going to say pause equals and just a blank list. And this list is going to hold the positions of our players. Now, actually, that reminds me, we're going to put two tuples in here. And these are going to represent, the starting positions of our players. So we'll start with 0, 0. And like 100, 100. So player 1 will start at 0, 0, player 2 will start at 100, 100, okay? And that's all we're going to do for that little list there. And then what we're going to do down here, this while loop is, we're going to keep track of how many players have connected. In our case, we only want 2 to connect, right? And then we need to keep track of, those players. So what we're going to say current player equals 0. Now, this is because when we connect, we're going to add 1 to this, so that when we go back into this function, it'll be, you guys will see how it works. But essentially, every time we create a new connection, so every time we accept a new connection, we're going to add 1 to our current player. So we'll actually do it at the bottom of the while loop. We'll say current player plus equals 1. This is just to keep track of which player we're using so that we know what position to update, what position to send to that player based on the connection, right? Okay, so keep track of current player. And now what we're going to do is when we start this new thread, so this threaded client, we're also going to pass another argument, which is going to be the current player. So instead of just passing connection, we're also going to pass player in here, okay? Current player, like that, okay? Because that's going to be important information to know. All right, so we're actually almost finished. We just got to update a few things. So let's actually grab these two methods from our client class or client file and throw them onto server here. So we're just going to put them right above position because we're going to need to use them. Read pause and make pause. So now when we initially connect to our player, right? This is what happens when we initially connect. The first thing that's sent is this encoded message that is connected. Now in our case, what we want to send is we want to send the starting position. So how do we do that? Well, we know what player we are. We're either player 0 or we're either player 1, right? Because we only have 2 players. When we start, we're player 0. After player 0 connects, then we do player 1, right? So what we'll do is we're going to send pause player. Now, that won't work because it's just a tuple, right? We need to first convert that to a string and then encode that string and send it. So let's actually go back here. I want to keep this string.encode. So string.encode, and we'll say make underscore pause, and then we'll just put pause player in here. And what that'll do is it'll convert it into a string for us, and then it'll send that to the player for us, right? And then they'll read that string in, convert it to a position, and update the position accordingly. Okay, making sense? I hope so. Okay, so that's how that works for player. Now, the only thing we need to change now is what information we are sending every time this loop is running, right? Every time we receive something from the player, we want to send back the other player's position. So to do that, what we're going to do is we're going to say con.receive.decode. So we'll get rid of this for now. And then what we're going to say is we're going to turn this data into like a readable tuple, right? So to do that, we are going to use the read position method that we've already created, or a function. So say read pause con.receive, and we'll turn that into, from that string like this, right? Or whatever it was, like 4567. We'll turn that into something that looks like this so that we can actually use it. Okay, so now that we have that, it's turned into that. What we're going to do is we're going to update our current player's position. So we're going to say pause player equals data, right? Because this is the position they sent to us. So let's update it on the server. So it's updated information. Okay, sweet. So we've done that. Now all that's left to do is send the other player's position back to our client. So to do that, what we can do is simply say reply equals, and we're just going to say pause, or actually, let's not do it up here. Let's do it down here. Okay, we're going to say if player equals 1. So if we're player 1, we're going to send player 0 position, right? So we'll say reply equals, and then pause player, or not pause, not player 0, sorry. And then else we're going to send, so we'll say reply equals pause 1. Okay, so if we're player 1, we send player 0 position. If we're player 0, we send player's 1 position, right? Like I was talking about with that little algorithm we're going to use. Okay, and then instead of saying received and sending, actually, yeah, we can say received reply, sending reply, or we'll say received data, sending reply. That should work fine. Okay, now what we'll do is we're going to send all the reply. But the thing is, our reply, we need to first convert into a string. So to do that, we're going to say make_pause, right? That function we've already created, and then that should actually be about it. Now I'm probably made a mistake or two here, but let's just test this out and see if everything's working. So let's start by running the server, and then let's run 2 clients and see if we can connect or if there's any errors. Okay, so we've connected with client 1. Let's run client 2, and let's see what happens. So I'm on client 1 right now, and you can see that when I move my green square, it moves on the other client. Okay, let's go to the other one. And when you look at this, when I move it on here, it moves on the other client. So we have successfully set up and connected our 2 clients together. Now, the only thing I want to change quickly is just the color of these so that we know who is who, like which square am I. So to do this, we're just simply going to go, we'll actually close this server class, otherwise you're going to run into an issue, or server instance, whatever it is. We'll go to client, and instead of having the same color here, we're just going to change this to be 255 for player 2. And now I want to show you what happens, because some of you are probably going to be confused with what's about to happen here, but it's kind of interesting. So let's run server, let's run client 1, let's run client 2. Now notice that these colors are inverted. Now, can anyone think of why that might be? So green, right, is going to be your current player. So right now I'm on here, I'm on this where my mouse is, and I'm moving the green square that's near the middle of the screen, okay? But notice on the other screen, it's moving the red square. That's because on your client, it's unique to you. So on your client, you are green and red is the other person. Meanwhile, if I go to this client and I start moving, see, green is me and red is the other guy, right? And he's not currently moving. Now, if I wanted to move these at the same time, I would just have to be running these on different computers, or I would have to change like the arrow keys to move them. And that's just because obviously, right, like if I'm pressing the arrow keys on here, it's not going to work on this client. But if I were to load up my laptop and try doing it on there, this would work fine as well. There's quite a few issues that we may run into when we're doing this. So I've set this up essentially to be kind of like an example program or like an example problem to give you guys an idea of the way we go about doing things in terms of server and network, but it's really not ideal the way that we've coded things so far. Now I did plan this for to do what we're about to do, but essentially I'm going to redo what we've just done in a much more elegant and nicer way that's going to allow for a better scalability of this program, okay? So what we're going to do is I'm going to redo it here. I'm going to show you how we can actually send physical, oh, not physical, but like send objects to the server and from the server back to the client rather than just string data. And then in the next videos, we're actually going to scrap all of this code that we've written, and we're going to start from fresh and code like a networking game that's going to be a lot more complex than just a few squares moving around the screen. So that's my plan for this series. Let me know what you guys think of that. I know it might be a little bit frustrating to get rid of this code, but now that we understand how a lot of this works, it's going to be really fast to rewrite it in a much more elegant way. So what I need to first start by doing is just taking this player class, okay? And I'm just going to copy it into its own file. So really straightforward. I'm just going to go to new Python file. I'm going to call this player with a lowercase, and then just copy that player class in there and just import Pygame up here, okay? Import Pygame. Now I'm just going to go back into client. We can delete this player class now. And what I'm going to do really basically is just from player import player like that, okay? And that's the first step. Now, remember I said we were going to send objects. So that actually means that we're not going to need this read pause and make pause thing. And it's kind of annoying how we've had to, well, take that tuple object, decompose it, turn it into integers, and then change object properties. And then when we want to send something, we got to put it into a string and we got to send it. And it's just a pain. And we don't want to have to do that, especially when we're sending tons of different bits of information, not just that same positional data, right? So we're actually going to delete this, and we can delete this client number. I don't know why I have that there. And we're going to start just making some modifications in terms of sending data and receiving data. So we'll start on the client side, and then we'll go over to the network, the server side, and fix some of that. So wherever we see like read pause and make pause, we can just get rid of that for right now. We don't actually need any of that. We're not going to need this p2.x stuff. We don't need p2.update. We'll get rid of all this for right now. And actually, let's get rid of start position. Let's get rid of p, and let's get rid of p2, and we're going to recode all this, okay? So actually, p2, p, yeah, that can stay there. p.move is fine. Okay, so we got rid of all that, and you can see we've just cleaned up this file a bit, and we'll start working with some more stuff in a second. Now, what I want to do actually is go to this network file that we have, and we're going to start making some modifications in here as well. So what we're going to be doing is we're going to be sending objects. So that means we're going to send like an instance of the player class. And that's actually what we're going to be sending, instance of a player class, to our server, as opposed to sending like string data and then updating the object on, or then updating the string data on the server, and then sending it back and then updating the object. That's just a lot of work. It's a lot easier just to send the actual object. So we can do that using something called pickle, okay? Now it's a weird module name, but it comes default with Python, and this allows us to do something that's called serialize objects. And that just means we turn it into byte information, which is like all the zeros and ones, send it over the, send it over the network, and then we can decompose that, turn it back into an object, and use that. And it's really easy to do that. So what we're going to do here is we're just going to modify a few things in our network class. So first thing, instead of having self.pause, we're going to say self.p, okay? This is going to be equal to self.connect. Instead of saying get position, we'll just do get p, and then we'll return self.p, okay? And that's all we need to modify for that. But now in the connect and the send, we're going to change a few things as well. So since we're going to be getting object data, what we have to do in the connect is we have to decompose that object data. So to do that, you do pickle dot loads, okay? Now what this stands for is it stands for load byte data, okay? And we'll talk more about this as we keep going through, but that's essentially what it means. And same thing here in send. Instead of encoding this data, what we're going to do, and I guess decoding as well, is we're going to dump it into a pickle object and then send it. So to do that, we're going to just say pickle, is that how you spell pickle? Yeah, dot dumps, like that, and we'll just put data in there, okay? And then when we receive, we'll do the same thing as before. We'll say pickle dot loads, and then we'll load that in. So now essentially what we're doing is we're going to be receiving an object, decomposing that object, getting the actual object, not the bytes form of it. And then when we're sending it, we're going to first, like, encrypt it, like send it into that byte information. And then on the server side, we'll decompose that as well, okay? So we'll go through that, but that's all we need for the network side. So now let's go to server and start making some modifications. So same thing here. We no longer need this read pause and make pause functions. We're not going to be using those. And we don't need this pause list either. We're going to change this actually to be players, and it's going to be equal to 2 new players. So notice that we're going to actually store the player object on the server as opposed to on the client side. And this is not only like safer because it means that the player technically can't really mess with the player objects. They can only like do commands to update them. But it's also just like, it's going to be a lot easier, and you guys will see how it works. We're going to say player, and we'll do another instance of player. And in here, what we're going to do is we're just going to create 2 new players. So we're going to say 0, 0, 50, 50, and we'll give it a color. In this case, the first color will be red. So we'll say red, green, blue, like that. And for the other player, we'll start him at 100, 100, like before. We'll do 50, 50, and then we'll make his color blue. Why not? So we'll do that. Okay. So now you notice that we're getting a little error for player here, just because we forgot to import it. So just say from player import player, like that. And that's why I made this a new file, by the way, just so that we'd be able to see it from the server side and the client side as well. And then wherever we're doing this like send encoding stuff, we're going to change this. So let's do that now, actually. So instead of con.send, instead of encoding some string information, we're just going to send the player object. So what we'll do is we'll say players, like this, and then player, right? So exact same kind of concept as before, in that we're going to send the initial like starting position of the player, or like the But in this case, we're just setting the initial player object, which means any information that's stored in that player will be given to the client as opposed to just the position. Okay. So next, what we'll do is instead of saying data equals read, pause, and decoding, we're going to get rid of this .decode and we're going to put pickle.loads. Okay. And actually, when I'm sending this player object, my bad here, guys, we got to do pickle.dumps. Okay. And then we're just going to have to import pickle up here. So import pickle. All right, sweet. Okay, so pickle.loads, pickle.dumps, and then it's obviously instead of pause player equals data, we're going to say player equals data. And again, same concept as before. What's going to happen is the client is going to send us a player object. We're going to replace the existing player object with that new player object, and then we're going to send back the other player objects, like the other client, okay? So now what we're going to do is just change these pause to be player or players, like that, okay? Same thing here, players. And then when we send it back, what we'll do is we will just turn it into a object, right? So we'll just do that pickle.dumps and send it back. So say pickle.dumps reply, like that. And that should actually be about it. So let's go back. Oh, sorry, there's something we need to do in client. So now what we're going to do is essentially we've set up our network class so that we're going to be able to send that object data. We've set up the server so we're going to be able to receive that object data. We're going to modify the objects we're storing in the list here, and then we're going to send back the other ones, so the other client. So in client, all we have to do now is set up player 1 and player 2 and then send that data. So really straightforward. It's very similar to before. What we're going to do, first of all, we're just going to say p1, or actually just p, I guess, is equal to n.getP. Okay, because in the network class, remember what we're doing is when we initially connect, so let's go back to server, we're just going to send the initial player object, which is going to be whatever player it is, so 0 or 1. So let's just say that this client's player object is going to be n.getP, okay? And then we'll say, actually, I think that's all we have to do for, yeah, that is all we have to do for that. Inside this while loop now, what we're going to do is every frame, we're going to send this player object, which we'll be updating with p.move, and we'll just get the reply and say that that's p2. So what we're going to do is we're going to say p2 equals, and then in this case, we'll just say n.send p. And that's all we have to do. And notice here that we don't have to do with all this like make, make pause, read pause, all that stuff. And I believe this should be working if I didn't make any mistakes. So let's cross the fingers and let's try this out. Waiting for connection. Let's go to client 1, run that, okay? And client 2, running that. And now notice that these rectangles are the same color. And watch what happens. If I move this red one, see how it's red on the other screen as well. Now that already shows us one of the advantages of doing it this way is that we can store information like color as well, not just position. And if we wanted to store maybe like there was a text attribute on each of these players, we could store that as well. If we wanted to store more information in the player, like a health or something like that, it'd be a lot easier to do that by just sending the actual player object that has like an unlimited amount of attributes rather than just sending that little tuple that has like 5, 6, right, which is the position. So the reason I went through the trouble of showing you the other way is to show you the massive advantage of doing it this way, and just to give you kind of perspective. If you're making something really simple and you don't use any objects, that's how you can do it with string data. But I think this way is a lot easier, and we've just cleaned up quite a bit of code. We've gotten rid of a bunch of functions, and moving forward, this is going to make things a lot easier for us. I'm pretty much going to be gutting everything we already did. We'll keep a little bit of it, but we're just going to really add to a bunch of that and just, yeah, we're going to be gutting most of it. And we're actually going to be working to create online rock, paper, scissors. Now, I know this sounds like kind of a lame game, but let me show you because it's actually pretty complex. And if you can understand how to make this game, then you're going to be able to understand how to make any other kind of online game because the principles are the same in terms of sending information, waiting for players to go, and there's a lot of different things that you might not think about that we actually have to do to code something like online rock, paper, scissors. Okay, so this is client number 1. I'm just running another Pygame window, or PyCharm window with the server running on it, and you can see obviously it's a bit oversized, but it says waiting for player, okay? So I'm going to launch another client. And then, excuse me, you can see when I launch that, it loads both of them up into the game, and it says your move, opponents, and currently it's waiting. So I believe this one's player 2 and this one's player 1. So if I make a move here on, let's say rock, it'll lock in my move. It says your move is rock. And then over here, it says, obviously the opponent's move is locked in because it's like looking for this guy's move. And now if he makes a move, like let's say scissors, then it says you win, you lost, and then it just resets and you can keep playing games. Now I'm also going to be adding more to this. This is just like the beta version. I'm going to have wins, ties, and losses, keeping track in the top hand corner. And when you load in, you're going to be brought to a menu screen, which will allow you to like start a new game or to leave, or we'll add that later as we go, but this is the main functioning game, and you can see obviously it's working well, tie game, and it restarts. This also allows for unlimited amount of clients to play. So for example, if I launch another 2 windows, you can see these guys now have their own game going. It's kind of difficult because I can't really get 4 on the screen, but anyways, if I go like scissors, paper, that works independently of these games, and these games can kind of play at their own time, which is really interesting and really cool. And if you disconnect one of them, it automatically disconnects the pair, and that's just because obviously you can't play against no one, right? So yeah. Okay, sweet. So that's that. Let's start getting into the code. Okay, so first thing we're going to do is we're actually going to code a game class, okay? And this is just going to be responsible for holding all the information for our game that we need. So for example, did player 1 go yet? Did player 2 go yet? What move did player 1 make? What move did player 2 make? Are both of them connected to the server? Information like that, and you guys will see how much information we actually need. It's also going to store things like keeping track of who won or who lost, how many ties, how many wins. So that's what we're going to do with this game class. So let's start making it. So class game, I'm doing this in its own file, by the way, just called game. You are going to need it in its own file because it's going to have to be accessed by both the client and the server, okay? We're going to define our initialization. In here, we're going to take ID. I'm going to say self.p1 went equals false, self.p2 went equals false. And obviously you guys know what this is going to do. It's just going to stand for if player 1 has made a move or not. If player 2 has made a move, we're going to do self.ready equals false, if I could type that correctly. We're also going to add self.id, so self.id equals ID, and this is just going to stand for the current game's ID. So each game we create is going to have its own unique numeric ID so that we can determine who's like what clients are a part of what game and whatnot. We're going to do self.moves equals, and then we'll just do none and none in here because currently the moves are none, but we'll just store 2 positions so we can change that. We'll say self.wins equals and then 0, 0. Obviously this one is going to stand for player 1, this one's going to stand for player 2, and we'll say self.ties equals 0. That's all we need for the init. So the next one is going to say get underscore player underscore move. Now what this is going to do is exactly what it says. It's just going to get, I don't know how I added that there. It's just going to get the player move that we asked for. So we're going to take P, which is going to be either 0 or 1. And what we're going to do is simply return self.moves and P. And just to remind ourselves, we'll say that P is in the range of 0 and 1. So we're only going to take value 0 or 1, and then we're going to return a move. So let's say move here, okay? And that's just to remind ourselves that we have to pass 0 or 1. Obviously 0 is going to represent player 1 and 1 is going to represent player 2. Okay, next one, play. So this one's a bit more complicated, not crazy. We're going to take play, we're going to take a player, and we're going to take a move. And what this is going to do is it's simply going to update our moves list with that player's move. Pretty straightforward. So what we're going to do here is we're just going to say if player equals 0, then what we'll do is we'll say self.moves 0 equals move. Oh, actually, you know what? Let's do this. Sorry, I'm just looking at my other screen right now. We'll say self.moves player equals move. But now what we have to do is based on the player, we have to update if P1 went or P2 went. Okay, so what we'll do in here is if it's player 1, obviously we'll do P1 went equals true. Gonna need a self before that. And then we'll just do a little else here because if it's not player 0, it must be player 1. So we'll say self.p2 went, if I could spell went, equals true. So that'll just keep track of if we've gone or not. Sweet. Next method, this one's really easy. It's going to be called connected. And this is just going to tell us if the 2 players are currently connected to the game. If they are, it will allow us to load in. And that's how we can determine whether we should show waiting for player or not on the screen, right? So we'll say return self.ready. And that's just going to tell us obviously if we're ready, and that'll be updated from the server side, which we'll do later. Next method, define both went. This is just simply going to return if both of our players went. So to do that, we're just going to say self.p1 went, and why can I not spell that word? And self.p2 went, like that, okay? Next one is winner. This one is a bit more complicated, but it's just going to keep track of, or it's actually going to tell us who's won the game. So if we call this method, we're assuming that both players have gone. We're going to check their moves, against one another and see if they won. So we're actually going to have to check 9 possible cases because there's 3 moves each player could do. 3 times 3, 9. So what we'll start by doing is we'll just say p1 equals self.moves 0 dot upper and then 0. The reason we're doing this is because we just want to get the first letter of the move, because the move is going to be stored as rock, paper, or scissors, the string, and it's just going to be easier for us to type out, for example, R or S or or P to check the moves, as opposed to having to check the entire word. So we're just going to get that first letter by doing move 0, we're going to upper it, and then we're going to take that first letter. We're going to do the exact same thing for P2, except obviously we're going to need, oh, I don't know what I did there. We're going to need moves 1 dot upper, and now we can start checking to see who's won. So we're going to say, to start, winner is equal to -1. Now that's because there could be no winner. There could be a tie. So if it's tied, we're going to say -1. If player 1 is the winner, it's going to be 0. If player 2 is the winner, it's going to be 1. Okay, so what we're going to do is we're going to say if P1 equals R and P2 equals scissors, what we'll do is we'll say winner equals 0 because player 1 won that. We'll say elif P1 equals S and P2 equals R. Then we'll say winner equals 1, I believe. Do another elif, and I know this is tedious, but this is the way you have to check for rock, paper, scissors. I don't think there's an easier way to do it. If you know an easier way, let me know. And P2 equals R. And if you guys don't want to type this, you can always copy it from my website, techwithtim.net. Okay, so say winner equals paper beats rock, so that'll be winner equals 1 or 0, sorry. We'll say elif P1 equals R and P2 equals P, then winner equals 1, and we've just got 2 last ones to check here. So we'll say elif P1 equals S and P2 equals R, and then P2 is the winner, so winner equals 1. I believe that's, oh, sorry, I might have messed this up. This should be P. I think so. P, rock, paper, scissors, paper. Yeah, winner equals 0. Okay, elif P1 equals paper and P2 equals scissors, then winner equals 1. And I believe that should be correct. 1, 2, 3, 4, 5, 6. Okay, sweet. And then the other cases are if it's a tie. So if none of this is the case, then they must have tied. And then all we're going to do is simply return winner like that. Okay. And one very last method, then we're actually done with this class. We can move to something else, is define reset went. And all this is going to do is say self.p1 went equals false and self.p2 went equals false. Pretty straightforward, and this is the game class. I know I kind of sped through this, but it's pretty trivial how this works. We just need to get this out of the way so we can start coding some other stuff. Okay, sweet. So we've done this class. Next thing I think we want to work on is network. So network, actually, you guys are going to have to modify yours to look like mine. Now get p and so this first half, so init and get p are going to be the same as what we had previously. The only thing that's changed is connect and this send. So in connect, instead of like unpickling an object, so like pickle.loads, what we're simply doing is we're going to just connect to the client like we did before, but instead of unpickling it, we're just going to decode it. So we're going to say self.client.receive 2048.decode. We'll return that value, and that's because when we initially connect to the server, what we're going to get from the server is our player number, which means we're either player 0 or we're player 1. Now that's important because that's going to determine where on the screen we're drawing certain things and how we're sending information back to the server and updating player 1 or player 2, right? Because technically each player thinks that they're player 1, but each one needs to be assigned either a 0 or a 1 by the computer so we know where to store information, right? Okay, so that's how we modify that. Just do decode instead of pickling. Sending, I believe, is the same, except what we're going to do is instead of pickling an object to send, we're simply going to send a string, and we're going to load an object. So that means we're going to send string data to the server, and we're going to receive back object data. So when we receive something, we have to pickle.loads it in, but when we're sending it, we just have to encode the string, okay? So just make sure it looks like this. I don't think I need to go through this. We've already done this for the past 2-3 videos, and that's the network class. So game and network are done. The next things to do are server and client. Now, server and client are a bit more complicated. So inside of server, I guess we could do this first because it doesn't really depend on the client to work, where the client kind of depends on the server. We're going to change a bunch of things. So this is what mine looks like now. I've kind of gutted the entire threaded client. I got rid of most of the stuff, like most of the other stuff. Just left this beginning thing. So the server IP, the port, the socket connecting, listening, waiting for connection. So by the way, some of you were saying you're having issues with fs.listen. You can just make this 0. It doesn't really matter what's in here. And some of you were saying like you're having issues, you can just delete it and type it in again. And apparently that works. That's what someone said. So I don't know, don't ask me about that. But if you're running into issues, do that. Okay, so what we're going to do now is we want to make it so you can have unlimited connections at once. Now that means we're going to have unlimited games running at the same time. So before, what we were doing when we had those players moving around the screen is we were just storing like player 1, player 2, and we just had a list that had 2 entries. That's how we were doing that. What we're going to do now is we're going to have a list that contains a bunch of different games. And those games, actually, it's going to be a dictionary. Those games will be accessed by their ID. And you guys will see how this works. It's a bit complicated, but just follow along. And yeah, so I gotta just open up my other file so I don't make any mistakes here. Okay, so what we're gonna do is we're gonna do connected equals set. We're just gonna define some variables. We'll talk about what these do. Games equals a blank dictionary, and ID count equals 0. So the reason we're adding these is games, this dictionary is going to store our games. So it's gonna have an ID as a key and the game as like a game object like this, okay, as the value. This connected is just going to store the IP addresses of the connected clients. We're storing in a set just so it's easier to access later. I don't actually know if we use this. We might, but we'll see, okay? ID count obviously is just going to keep track of our current ID. So that means what game we should recreate so we don't override games and say like 2 games have the same ID, because obviously we can't have that happening. Okay, so that's fine for that. We're not going to deal with anything in threaded client right now. We're going to go down to our while loop, and this is where we're going to create new games based on new people joining or possibly delete games. Actually, we'll delete games from threaded client. So what we're going to do right now is when someone connects, this runs, right? And we run a new, so like once we accept a connection, everything after this runs. So what we're going to do is we're going to say ID count plus equals 1. If you notice me looking away, I'm just looking at my other screen to make sure I don't make any mistakes on this. Now, what ID count plus equals 1 is going to do, obviously, is it's going to keep track of how many people are connected to the server at once. Because obviously, right, like once this happens, we accept, then we go down the while loop, we start a new thread, and then we wait for another connection. So we're just going to keep track of that. What we're going to do is we're going to say p equals 0, just standing for the current player. And we're going to say game ID equals, and this is going to be weird, but just follow along with me. What do you call it? ID count minus 1 integer division 2. Now what this is going to do is essentially every 2 people that connect to the server, we're going to increment game ID by 1. And what game ID is going to be, or we'll say it's, yeah, we'll add it by 1. What game ID is going to do is keep track of what ID our game is going to be. So like, for example, if we have 10 people connected to the server, we're going to have 5 games, right? So that's what this line of code is doing for us. It's keeping track of how many games, or if we need to add a new game. Because obviously if we have like 6 people connected, all of them are going to be playing each other. A 7th person connects, well, it doesn't have a game to join. We have to create a new game for it to join. Hopefully that makes sense. Okay, so what we'll do next, we'll say if ID count modulus 2 equals 1. And what this is going to stand for is if you're going to be player 1 or player 2. And if this happens, is actually we need to create a new game, because this means that we don't have a pair for our new player. So for example, like say this number is 3, that means 2 people are already playing. So that's 1 person just connected. So we need to create a new game. That's what this modulus 2 is getting. Okay, so to do that, we're going to say games game ID equals game ID. Okay, and I believe this actually has to be capital. So obviously, sorry, at the beginning of this, I forgot to mention I imported game. So from game, import game. That is important. And yeah, essentially what we're doing is we're just going to say that game ID, which is that key in our dictionary, is now equal to a new game, so we can access that and add players to it and whatnot. Sweet, so that works. Let's actually print out a message here and just say creating a new game, ... just so that in our server we get some kind of output and we can have a look at that if something's going wrong. So otherwise, if we don't need to create a new game, meaning we have, let's say, 3 people are connected, so that second game already exists, and another person connects, well, that person has to be a part of this new game. So what we're going to do then is we're going to say games, game ID dot ready equals true. Now what this means is that the second player connected, so there's 2 players now connected to our game. So now we can say that that game is ready to start playing because both the players are connected. So that means that they can, well, obviously play against each other, right? So that's what we'll do. We'll set that dot ready equal to true. And obviously we're storing all the games on the server side as opposed to on the client side. And then what we're going to say is we're going to say p equals 1. And what this means is player equals 1. And you'll see why we need to do this in a second. Okay, so now we're going to do start new thread. Now notice in start new thread, I added 2 new parameters, p and game ID. So this means the current player, so it's either player 0 or player 1, and the game ID. And game ID is going to stand for which game in this game's dictionary are we playing in this threaded client. Like which one of our clients that's connected here is playing which game. That's why we need that. So let's pass that information. So we're going to pass p, which is either going to be 0 or 1, like we have there, and we're going to pass game ID. And then we'll have that up here. And just remember that threaded client, one of these functions is continuously running for every single one of our clients. So if we have 100 clients, we have 100 different functions of this running in the background at the same time. Okay, awesome. So that's how that's working inside our threaded client now. Excuse me, I just had to take a break there. Inside of our threaded client, we now need to add some things. So the first thing we're going to add is ID count. We're going to global ID count because if someone leaves our game or disconnects, we're going to need to subtract from that so we can keep track of accordingly, like how many people are connected, how many games are running, and all that stuff, okay? Now the first thing we're going to do when someone connects to our, our server is we're going to send them what player they are. Remember what I was saying in this game class, or in this network class, sorry, that when we connect, we're initially just going to decode a string that's either going to be 0 or 1 to tell us what player we are. Okay, so what we're going to do is we're going to send con.send str.encode p. And I believe it should be actually string p, like that, so that we know if we're player 0 or if we're player 1. That's the first step. Next, we're going to say reply equals a blank string. We're going to say while true. And this is where we're going to start doing some more serious stuff in here. So the way that it's going to work in terms of sending string data from our client to our server is we're going to send one of 3 different options. We're going to send get, we're going to send reset, or we are going to send a move. And the move is going to be like rock, paper, or scissors. So if we send get, what that means is we want to get the game from the server. So we're going to send that every frame. We're going to send get, that string get. And then the server is going to look and it's going to say, okay, what are you sending? You're sending get. All right, we'll send you back the game. That's how that's going to work. Another option is reset. Reset means reset the game has finished, both players played, reset. And that's going to be sent from the client side because the client knows when we want to reset, right? The last one is a move. Same thing. When the client makes a move, so like rock, paper, scissors, if they are allowed to make that move, which we'll check on the client side, we'll send that move to the server will update the game accordingly, and then it will send back the game to the client. And that's how that's going to work. Sweet. So what we'll do now is we're going to say while true, we're going to say data equals con.receive, and then we're going to say 4096 in here instead of 2048, which we were using before, .decode. The reason we're doing this is just in case we're sending too much information that is more than 2048 bits. We want to just double this number so that we can get more. If you run into any issues that say like pickle data was truanced or like ran out of input, just increase this number, okay? You can literally just do multiply by 2 in here, and that should hopefully fix the error. If it doesn't work, you can like multiply by 4, multiply it by 8, and that should hopefully fix your error for you. Okay, so now what we're going to say is we're going to say if game ID in games. Now, I'll talk about why we're doing this in a second. What we're going to say is we're going to say game equals games game ID. So essentially, every time we run this while loop, we're going to check if the game still exists. And that's what we're doing, right? So in this games dictionary, we're seeing if this game ID, which is the key to access the game, is still there. Now, why would we check that? Well, if one of our clients disconnects from the game, we're actually going to delete that game from the, the games thing. Now, what that's doing for us, excuse me, is not only like keeping track of our memory, which means that we're not going to just continually keep creating games. So like say our server ran for weeks and we never deleted any games, then we'd probably run out of memory on our computer, right? If we're playing a lot of games. But it's also going to tell the other client that was connected to that game that, hey, this game no longer exists. That means the other person must have disconnected from it. So we have to do something accordingly, go back to the menu screen, right? Do something like that. Okay, so that's what we'll do there. And then what we're going to say in here is going to say if not data. We're going to break. This is similar to before, so I'll go through it a bit quicker. We're going to say else, and now we're going to check the 3 different things that could have been sent, right? So we've received the data, so we're going to check if we got reset, get, or if we got a move. So the first thing we'll check, we'll say if data equals reset, okay? And then we're going to say if data does not equal get, and then else, sorry, this should be an elif data does not equal get, else we'll do something else. Actually, do we need an else? No, we don't need an else. Okay, so if data equals reset, what we're going to do is we're going to say game.reset, right? Because we already have the game, and if we look in here, what reset's doing is essentially it's resetting both players once so we can play another game. Really straightforward for that. Next one, if data equals get, what we're going to do is say game, or if data does not equal get, sorry. So if it didn't equal reset, and it does not equal get, well then it must be a move. So it means we're either getting rock, paper, or scissors. So we're going to send that move to the game to update it. So to do that, we're going to say game.play, and then we're going to do the current player number, which is P, and then the move. And the move is going to be whatever this data is, right? So it'd be data. Okay, and then otherwise, so I guess after that, what should we do here? We'll say reply equals game, and then what we're going to do is we're going to do con.sendAll, and we're going to say pickle.dumps, and not data, sorry, reply. Okay, and what this is going to do, let me just make sure I didn't run into any errors here, is simply going to package up our game into that nice sendable form. We're going to send it over to our clients. Client's going to receive it, unpickle it, and then use it to obviously make moves and do different things and draw it to the screen and all that, okay? All right, so I think that makes sense. We can go through it really quickly. What time are we at? 25 minutes, all right. So we'll go through it really quickly. Essentially what's happening when you connect, we're going to check if we have an even amount of players or an odd amount of players. If it's an odd amount of players when you connect, that means we need to create a new game. So we create a new game. If it's not, that means we need to assign you to a game. So what we're going to do is make the current game that only has 1 player in it ready. We're going to assign you to that and start a new thread. When we start the new thread, what's going to happen is we're going to send to the client what player they are, either player 0 or player 1. And then what we're going to do is we're going to constantly receive string data from the client. If the game still exists, then what we'll do is we'll check if they're sending us reset, get, or a move. If they're sending us a move, we'll make that move. If they're sending us reset, we'll apply that reset to the game. And then we're just going to constantly send back to them the game object. And now what we need to do is just really quickly add some else statements in here so that if some of this stuff doesn't happen, we have like a catch for it, okay? So what we'll do here is we're just going to simply say else break, okay? That should be lined up here. And we're just going to add a try and except up here. So we're going to say try, and we're going to indent all this by just highlighting and pressing tab. I'm going to say except, and then pass. I think that's, yeah, no, not pass, sorry, except, and then break. Just in case, you know, something goes wrong with this data.receive, we want to make sure the server keeps running. So we have that try and except. And then underneath this except, in line with the main function indentation, what we'll do is if we break out of this while loop, we need to close the game and delete it. So to do that is actually we're going to print, I'm on my wrong file here. We're going to print lost connection, and then we're going to print, closing game. Okay, and actually we can print that game ID too if we want to see what game ID we're closing. So we'll say lost connection, closing game, game ID, okay? And then we're going to try to delete games, game ID. Otherwise, we will accept and pass, okay? And then underneath here, last thing we're going to do is we're going to say ID count minus equals 1, and we're going to say connection dot close. Now that I actually think about it, we should probably put this closing game only in this try after we delete, just so that we only close the game once. We don't say we're closing the game twice, okay? So what we're doing down here essentially is if we break out of this while loop, so for example, if the game no longer exists, we're going to break. If something goes wrong with this getting data, so like the player disconnected, we're going to break. We're going to say lost connection. We're going to try to delete that game. The reason we have this try here is because if both players disconnect at the same time, one player will delete the game before the other. So if we try to delete a key that doesn't exist, we're going to run into an issue. So we try that. If that works, we will say print closing game, and then we'll say that game ID. Otherwise, we're going to pass. We're going to subtract from the ID count, and we're going to close the connection. Sweet. So we're rolling. We're going pretty fast here. Now all we got to do is code the client. Now, this is probably the most amount of code. I think it's about 100 lines. It just is a lot of drawing stuff, okay? So I'm going to take a break. I'll be back in 1 second, and then we're going to code the client. All right, so I'm back now, and we've got about 150 lines to write for this file. It's pretty tedious because a lot of the stuff is to do with the drawing. Like, we need those buttons to be working. We need, like, all that text to be showing up. So that's like 90%, or not 90%, but like 70% of the code we're about to write is just going to be cosmetic stuff. But I mean, what do you want me to tell you? That's what we need to do if we're going to make an online graphical game, right? So let's start by just coding a class, and this is going to be our button class, just so that when we have those 3 buttons, you know, it just makes things easier. So we're going to do our init. What do we need in the init? We're going to go for text. Sorry, I'm coding in the wrong file. Text, X, Y, and color. And we're just going to say that the width and the height will be uniform in here, and we'll just make it the same for all of our buttons. So we're going to say self.text equals text, self.x equals x, self.y equals y, and self.color equals color. Okay, sweet. We'll also add a width and a height in here, so we'll say self.width equals 150, self.height equals 100, and feel free to play with these numbers. This is just what I decided. By the way, guys, just really want to say this. I'm not focusing on how good this game looks. I know it looks like crap, but you guys, I know, can go through and tweak the colors and tweak the positions and all that. I just didn't want to focus on that because I want to get the hard stuff out of the way in the tutorial. Okay, so let's do a draw method in here. Pretty straightforward. We're just going to do pygame.draw.rect. And then for the rectangle, we're going to take window, which is that parameter for the draw. And then we're going to do, what should we do? Color. So self.color, and then we're going to need that rectangle position, which is going to be self.x, self.y, self.width, and self.height, like that. Okay, and then I guess let's see if there's anything else we need to add to that. No, that's fine. We're going to define a font. So we actually need to make sure we just add this at the top, pygame.font.init. Okay, make sure you guys add that. And we're going to do font equals pygame.font.sys font. Should help if you spell font correctly. And then in here, you're going to pick your favorite font. I like Comic Sans. I'm going to make this, how big should this be? Let's make it 40. And then what we're going to do is we're going to render some fonts. So we're going to say text equals font.render. And we're going to put self.text. We're going to do 1. And we're going to do the color, which will be, I guess in this case, black or white. 255, 255, 255. Okay, next we're going to draw this on the screen. Now we want this to be centered on the button, so I'm going to do some, like, I don't know, decently complicated math. It's not really that crazy, but we're going to just say win.blit text, and then we're going to say self.x minus, is it minus? No, it's plus. Self.x plus in brackets, and we're going to round in these brackets. I know this is confusing. We're going to do self.width over 2 minus round. And we're going to say text.get_width over 2. Now, what this is doing essentially is we're starting at our X position, but obviously we want our text to be centered. So to center our text, we need to know not only the width of the container of the button, but the width of our text. So we're going to get the width of our text, or of our button. We're going to subtract that from the width of our text. So that way it should add like 20 or 30 pixels from the left side, so our text is centered. Okay. For the Y, we'll do a similar thing. So inside, make sure you don't mess up these brackets. Inside here, we're just gonna actually copy this, and we're gonna paste it right after a comma, and we're simply gonna say self.y plus round self.height. Okay, plus text.get underscore height, or minus text.get underscore height over 2, and that should center our button. Yeah. Okay, next we're gonna say define click. We're gonna add a position here. This is just gonna tell us if we clicked on the button or not. So it's a really basic if statement here. So we're just gonna say x1 equals pause 0 and y1 equals pause 1. Now what we're gonna say is we're gonna say if self.x is less than or equal to x1, less than or equal to self.x plus self.width, and self.y is less than or equal to y1, less than or equal to self.y plus self.height. I believe that's correct. Let me just check this. Yep, that's correct. Then what we'll simply do is we'll return true, indicating that we did press the button. Otherwise, we will return false. Now, I know I'm speeding through this, but it's just because it's really basic Pygame stuff and we're doing online games. So let me make sure I change that. So I don't want to focus too much on the cosmetics, but essentially what this is doing is it's checking if the coordinate, which we're going to pass in here, which is going to be a tuple of x and y of our mouse position, is actually in the button. And the way we're doing that is we're saying, well, we go on the x, right? We check if it's greater than the x. We check if it's less than the x plus the width. So like if it's in between the little box. And then for the y value, we do the same thing, but we're checking vertically to see if it's in that box. If you don't understand that, I have Pygame tutorials where I go through like collision and how all that works. I'm not really going to talk about that right now. Okay, sweet. So we got that working. Now what we're going to do is actually, let's see what I want to code now. Let's code the main function, and then we'll get into redraw window. So the first thing we're going to do is we're going to define those 3 buttons that we're going to have at the bottom of our screen. So rock, paper, scissors. Do that. We're going to say buttons equals, and we're just going to make 3 buttons. First button will be rock. So we're going to say rock. We're going to start it at 50, 500, and then we're just going to go and give it a color of 000. Okay, we're going to create another button. We'll say button, and then we'll say scissors. We'll give it a, let me just check here, 250 as an X, 250 as an X, 500 as a Y, and for the color for that, I gotta check what color I made this. I believe that I made that, red. Okay, so we'll go 25500, and then one more button. Can anyone guess what this one is gonna be? It's gonna be paper. We're gonna put this at a position of 450. So if I can go here, 450, 500, and we will simply make it blue, or green, sorry, 0, 255, 0. So red, green, blue. Okay, sweet. So that should be it for our buttons. And now we'll get into the main function and start coding some stuff. The first thing we're going to need to do is we're going to need to say run is equal to false, or is equal to true. I always do that. We're going to say clock equals pygame.time.clock, capital C here, my bad. Okay, next we're going to say n equals network, right? Because we're importing network up here. We're going to do a very similar thing to what we did before in all the previous tutorials, where we just connect initially by doing that initialization, and then we're going to say p equals, actually player equals n dot get p, right? And you should already have that method. It's just returning that like connect what we connected to, right? So when we connect, we get the player number, which is either 0 or 1, so we need that. Now it reminds me, it's going to be a number, so we got to put an int around this so that we can compare it with other integers. Okay, and last we're going to just print, just so we have this, you are player. Now this just indicates to us like when we initially run, if we know we're 0 or 1, just to make sure everything's working fine. Now we're going to make a while loop. We're going to say, this is our main game loop. We're going to say while run, and then in here we're going to do clock.tick 60. Very similar to what we've done before, guys. I'm going to start adding some new stuff in a second. Okay, so now that we've done this, it's time to start actually connecting and asking the server for information. So what we should be doing here is every frame, we should be asking the server to send us the game. especially at the beginning of this loop, because right now we haven't actually created a game class, right? We need to get that from the server. So we're connected now. We know what player we are. So now what we can do is we can try to get that from the server. So to do that, we're going to say game equals n.send get. And that's literally as easy as it is. We just need to do an accept, and then we'll just, We'll say run equals false, and we'll say print couldn't get game. Okay. And the reason we're doing this, and then we're going to break as well, is because if we send this and we don't get a response from the server, that means the game doesn't exist. And if that happens, well, then what we should do is we should exit out of this game. We should print saying we couldn't get the game, and then we should try to reconnect or start a new game with someone else. So this main function is going to be like the actual game running, but once we exit out of this main function, we're going to go to a main menu, and the main menu will allow us to choose like who we want to play against and a bunch of other stuff as well. Okay, you guys will see that later. Okay, so that's how we do that. Next, what we're going to do is we're going to say if game.both went. Now, what we're going to do here is if both players went, well, we're not waiting for anything now. We need to see which one won. So what we're going to do here is we're going to check which player won, and we're going to display that message accordingly on the screen. So what we're going to do initially is we're going to redraw the window. The reason we do this right away is because we want to make sure that if both players went, we're updating the window, and on the window it'll check like if both players have gone, like in this redraw window, and it'll draw the player moves for us. So you guys will see how that works in a second. We're going to do a delay. We're going to do pygame.time.delay 200, and now what we're going to do is we're going to try game equals n.send reset. Now why we're doing this obviously is because, well, if both players went, we need to tell the server to reset those player moves, right? So inside a game, if we call reset went, we're just going to reset it so that we were able to play the next round after. Okay, we're going to accept, of course I can't spell that. We're going to say run equals false. We're going to do the same thing as before. We're going to print couldn't get game, couldn't get game, and then we're going to break. Okay, now under this, so after we send that reset, now what we want to do is we want to display a message on the screen indicating whether player 1 won or player 2 won, or like if you won or if the other player won. So the way we're going to do this, and it's actually a decent amount of lines, is because we have to like render font, and then we got to determine where we're going to draw the font and what's going to be on the font. So we're first just going to start by defining a font. So we'll say font equals pygame.font.sys font. Okay, in here we'll say Comic Sans. Font size, let's go 90 for this one. Now we're going to say if game.winner, and remember if we go to game, winner is going to respond to us with either a 0, a 1, or a -1. So we have to check if winner is 1 and player, so whatever our current player is 1, then we're going to say you won. If winner is 1 but the current player is 0, we're going to say you lost, right? So that's how we can check this. So to do that, we're going to say if game.winner equals 1 and player equals 1, and remember we got that player from the server, so we know if we're either player 0 or player 1 on the client side. And do I need an and? Or that's what we need to do. Or game.winner equals 0 and player equals 0. So essentially what we're going to do here is we're going to check if this player won. So we know what player we are and we know what player won. So if that coincide, like what player we are and the player that won, then we'll print out and we'll say, or we'll put on the screen, you won, right? Telling that client they won. So we'll say text equals font.render. And then in here we simply say you won, exclamation point, and then we can just do 1 and then a color, and obviously color we just do like red like that, okay, on the screen. Okay, so else, elif, and now we're going to check if they lost. Well, actually I think we could do this easier. We're going to say elif game.winner equals -1. So if we tied, what we'll do here is we'll say text equals font.render, and we'll just say tie game, exclamation point 1. Again, we'll put that in red. Okay, and now else, so if we didn't win and we didn't tie, we must have lost. So we can literally just copy this and we'll just say you lost as the text. Okay, so you lost dot dot dot. Sweet. And now what we're gonna do is just render that font, put it on the screen. So, or not render it, just put it on the screen. So we'll say win.blit text. And now we're gonna do the exact same thing that we did before to get it in the middle of the screen, just be a little bit easier. So we're just gonna say, I believe, do I need another brackets? No, I don't think so. We'll say width over 2, and that's the width of the actual screen, minus text.get underscore width. We need those brackets over 2. We're gonna do comma, and now we'll just do the same thing with height. So we'll say height over 2 minus text.get underscore height over 2. Okay, so that's gonna put it in the middle of the screen. We're gonna update the display, pygame.display.update, and we're going to delay. So pygame.time.delay, and I'm gonna put 2000 for 2 seconds. You guys can put whatever you want in here. Okay, so let's break this down really quickly. If both players went, that means now we get to check who won. So what we're going to do is we're going to redraw the window. We're going to, apply a small delay of 0.2 seconds, just so that we can see what both players did before it immediately pops up who won and who lost. So actually, let's make this delay half a second. We're going to send to the server reset. So we're going to reset both players went, so that the next time that we start playing, both players are allowed to move. We're going to say run equals false if this doesn't happen, if this doesn't work. We're going to print couldn't get a game, we're going to break. Now otherwise, so like if this worked, we sent the game, we're going to create a font, we're going to check who won, so either we won, we tied, or we lost. We're going to display that to the screen, we're going to delay for 2 seconds, and then we're going to play the game again after. Okay, awesome. So we're almost done. We're just going to add this pretty actually complex for loop in here. So what we're going to do now is we're going to say for event in pygame.event.get, very standard for Pygame. You've probably seen this before. I'm going to say if event.type equals pygame.quit. Then what we're going to do is we're going to say run equals false, and we're going to say pygame.quit. So this just means that they hit that little X button at the top of this corner. Now we're going to check if they actually press their mouse button down. So this is how we're going to check if they pressed a button. This is what we're going to do now. Let's say if event.type equals pygame.mouse button down. Then what we'll do is we'll get the mouse position. To do that, we're going to say pygame.pause pygame.mouse.get underscore pause. So what we're doing here is we're checking if they press right, middle, or left mouse button. If they do, let's get the mouse position. Now, for every single button, we're going to check if we click that button. If we did, we're going to do something accordingly. Okay, so what we're going to do now, I'm going to say for button in btns. Remember, we defined buttons up here. Then what we're going to say is if btn.click pause. Now, if they did click the position, there's a few things we need to check. Oh, and also we need to check this, sorry. And game.connected. Sorry, so what this game.connected is doing is just making sure that it's not going to let us press like rock, paper, scissors unless both players are on. So that's just so that we don't run into an issue where we can make a move before the other player connects. Okay, so just add this and game.connected. What we'll do now is we're going to check what our current player is, because this is going to determine how we send a move. So what we're going to do now is we're going to say if player equals 0, if not game dot p1 went, then we'll do something. Otherwise, so we'll just put else here, and we'll check if not p2 game.p2 went. Okay, so what we're doing now, and I haven't coded the rest of it yet, is we're just going to check if we press one of the buttons. So remember, we have that click method in our button that tells us if we clicked on it. So if we do click on it and we're connected to the game, what we're going to do is we're going to check if our current player is 0 or 1. Now, what we're doing is if we're player 0, well, we're going to check if player 0 has gone yet. If they've gone, obviously we're not going to let them make a move, right? Because they've already made that move. They can't change their move once they made it. Same thing with player 2. So if we're not player 0, we're player 1, clearly. So that means we're going to check if player 2 has gone yet. And if they haven't gone, we'll allow them to move, okay? So what we'll do in here now is we're going to make a move. Now to make a move, remember, we just need to send to the network our move. So we're just going to say n.send, or to the server, sorry. And all we're going to do is we're just going to send the text of the button. Now the text of the button will be rock, paper, or scissors, right? And that's precisely the move that we're going to make depending on what button we're clicking. So it's a really nice dynamic way to do that. Now, once we've done that, right? So if we go to server, what happens here is if we send that, we're going to play that move and we're going to update it on the game so that the other client, when it gets that game board again, will have that updated move. You guys will see how this works in a second. Okay, so that's working well. Now all we need to do is just add in line with this right here. We're going to say redraw window. We're going to give it win. We're going to give it, what else do I need to give it? Game and P, which stands for our current player. And that's actually it for, and make sure you just are calling main down here at the end of client. That's actually it for this main function. So now all we need to do is do redraw window, and we're really close to done. So we got another like 20 lines, and then once we do that, we're actually finished this game. And then we can start testing it out and talking about some more things we can add to it, okay? So what we're going to do now is, yeah, this is actually quite a bit of work, is we're going to draw all the stuff on the screen now. So we've done all the logic aspect of it down here in this main function. But now we need to draw everything. So it's more tedious than it is difficult. But we're just going to first start by checking if not game.connected. Now this just means if we have not yet had the other player connect, then all we're going to do is we're just going to print on the screen waiting for player, and we're not going to show anything else. So to do that, we're going to say font equals pygame dot font dot sys font. Name obviously is Comic Sans. And then how big should it be? Let's make it 80. Okay, and then we're going to say text equals font dot render. In here we're going to say waiting for player dot 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 one color. Let's do nice red, and let's actually add true here for bold. Okay, so we're going to blit this on the screen. So to do this, we'll say win dot blit. And we're going to do, again, that same, I know, a tedious thing to get it in the middle of the screen. So we're just going to say width over 2 minus text dot get underscore width. And then we're going to say height over 2 minus text dot get underscore height. And actually, we need to make sure we're dividing both the width and the height by 2. So let's do that. Okay, that's it for that. Now else, so this means if we actually are connected, both players are in, now it's time to start drawing the real stuff on the screen. So we need to draw that, what was it? So actually, let me pop up client for you guys so you can see what it looks like. Let's run server, run client. Right, so if we want to see the client, what we should do is we need to draw this, and then the 3 buttons. Okay, so we're gonna have to do these 4 texts. And the thing is, these texts need to change they're going to be different depending on what player is looking at it, right? So for example, here it's showing us what our move is, but notice it just says locked in for opponents. It doesn't tell us what our move is or what the other player's move is, right? So we need to do that as well. Okay, so to do that, let's start. We're going to make another font. I'm going to say font equals pygame dot font dot sys font Comic Sans. Size of this font, let's make it 60. And then what we're going to do is we're going to say text equals font dot render. And we're going to do your move. So we're going to start by just doing your move and like opponent move, because those aren't going to change. They're going to stay the same no matter what. And for that, we're going to do 1. And the color I had there was like a nice cyan, I think, right? So we'll do this. Feel free to change the color. I know it probably doesn't look the best. And let's just split this at a static position on the screen. So we'll say text. And let's go 80, 200. Okay. All right. Next. So actually still in this else statement, we're going to copy this. What am I doing? Just this text and this win part. And we're going to put it down here. Instead of your move, we're going to say opponent's move. Is that how you spell that? Let's change that to opponents. And actually, let's just get rid of moves. It's going to be too big. Opponents and same color, except we're just going to change the X value so that we draw it at, 380, like that, okay? So that's it for your move and opponents. Next, what we need to do is a bit more complicated, because now we have to draw what the actual moves are. So remember, we don't want to show the other player what one of the player's moves is unless both of them have gone. It's like we want to know what our move is, but we can't know what the other player's move is until we've both made a move. So to do this, what we're going to do, we're going to start by just getting both player moves. So we're going to say game.get underscore player underscore move. We're going to get move 0, and we'll copy this and just do move 2 and change this to 1. So we'll start by getting the moves, and then now we're going to check if we should show those moves, if we should show waiting, or if we should show locked in. Okay, so to do this, we're going to say if game.bothWent, okay, like that. What we're going to say is we're going to say text1 equals font.render, and we're just going to use the same font as before. And what it's going to be is move1, comma 1, comma, and we'll make this black, so 0, 0, 0. Okay, and we'll copy this, and we'll do the same thing, except text2 is going to be equal to move2. So essentially, this is saying if both of the players have gone, well, we can show their moves because they both made them. So let's do that. And it's just rendering that font. And we'll display the font after. You'll see how that works. So now, otherwise, if both players have not gone, what we need to do is we need to, actually, let me just check something for a second, is we need to determine if we're going to show locked in, meaning the other player actually has gone, but we're not going to show their move, or if we're going to show waiting, which means the other player hasn't gone. So to do this, we're going to say if game.p1went and p equals 0. So this is saying if we have gone and it's our current, like we are the player, we're player 1. So if player 1's gone and we are player 1, what we're going to do is we're going to say text1 equals font.render move1, which is the move we've done, which is fine if we see that. And then we're going to say 1 and color 0, 0, 0. Okay, elif game.p2 went and is this what it is? Actually, sorry. Game.p1 went. You guys will see how this works in a second. What we're going to say, we're going to say text2 equals the same thing. Now, this might be confusing, but essentially what this is doing is it's saying if player 1 is gone and we are player 1, we're going to say, if I spell render correctly, render, like that. Render. Sorry, I got interrupted there. Okay, so if player 1 is gone and we are player 1, then we want to show underneath like your move what our move is. Otherwise, what we want to show is we want to show that like locked in. So we're going to change this to locked in underneath opponent's move because it means player 1 went, but it's not us. So it's not our move. So that means we want to show it under opponent's move. So you'll see how this works. We're going to say locked in like that. Okay. All right. Now we're just going to do else. So this actually just stands for if game.p1 hasn't, like if they haven't moved yet, we're just going to say text2 equals waiting. So we'll say waiting dot dot dot. I believe that's correct. Actually, sorry, these all need to be text1. My bad. Okay. All right, I know this is confusing, but we'll go through it after. All right, so we're going to actually copy this, and we're just going to change everything to 2. So this is going to be P2, this is going to be 1, this is going to be 2, this is going to be 2, and this is going to be 2, and this is going to be 2 as well. And let me just make sure that I did that correctly. I believe I did. Okay, sweet. And now we are going to actually show these. We're going to blit these on the screen, and we're actually really close to finish, guys. So to do this, we're going to say if P equals 1, so if we're player 1, what we'll do is say win.blit, and we'll say text2, and then where we're going to show it, we're going to show it at 100 and 350. Okay, now we'll copy this, so Control D, and we'll blit 1, except instead of at 100, we're going to change this to 400. Now we're just going to put an else. So if we're not player 1, clearly we must be player 0. So we're just going to reverse these, player 1, player 2. Now the reason we're doing this is because this is going to be where like player 1 and player 2's moves are shown on the screen. So we want it to make so that for each of our clients, rather than saying like player 1, player 2, and having one of the clients have their move on the right side and one of them have it on the left side, we want it to be the same for each client. You guys will see how this works when we actually run the thing. So let's actually just let's add in drawing the buttons. So to draw the buttons, we could draw them in this else statement. Actually, that might be better. Yeah, let's do it inside of this else. Okay, so we're gonna say for btn in buttons. We're just gonna say btn.draw and give it a win. And I think that's actually all we need to do. And lastly, we're just gonna update the display. So pygame.display.update. Now, assuming I didn't make any critical errors, this should actually be working. So I know this has been a lot of code and a lot of writing, but I think I've kept it to just about an hour now, actually. And that's actually a pretty decent time for creating a game like this. So you guys will see how this works out. Okay, so let's try running our server and see if we get any errors first of all. Okay, server, waiting for a connection, server started. Good sign so far. Okay, clients, let's try running a client. So I'm gonna go client, Oh, name P is not defined. When game P. Okay. So what we're going to do for client, this is a really easy fix. Just change this to player. And I might have to change. Oh yeah, up here when I do redraw game window as well, we got to do win, game, and player. Okay, so fix that. All right, client, run. Waiting for player. All right, good sign. Let's run another one. And what do you look at that? Okay, they both launch in now. So you saw that waiting for player showed up, but as soon as we are ready, now both of them are showing up. Okay, so this should be player 1. This should be player 0, or player 1, player 2, right? Okay, so let's try this now. Rock. Ran out of input. Self.client.receive 2048. Okay, so let's just have a quick look at why this might be. So I think I might have found the issue. I don't know if this is the issue exactly, but we do need to fix this. Where I do game.reset inside of server here, it actually needs to be reset went, because that's what I called it inside here, reset went. So we just gotta make sure we do that. Okay guys, so really silly error here actually. The issue was on the server side here. I'm calling play, right? Like game.play. And so actually I need to get rid of this. I was just printing out the exception so I could see what it was. But essentially play doesn't actually exist because I misspelt something on game. I misspelt it. I misspelt player. It should be play. So that was the issue I was running into. It was very difficult to see because it was just accepting it and not printing anything out, just continuing to run the server, so I couldn't find it. But essentially if we run the server and we run the 2 clients now, we should have everything working. I haven't actually tested it, so let's pray. If I go paper, sweet. So it goes paper here. We're not getting locked in over here, so that might be an issue, but let's see if we make something here. Then it's since you lost and you won. Okay, so we have a slight issue, but it's pretty easy fix. Let's just go up to client, just look through. We're just probably messing something up in the drawing code here. So, oh, that would make sense. Well, we're not actually end up drawing. Yeah, so this, if P equals 1, this just needs to tab back one indentation level. And now we should have everything actually working fine. So let's try this now. Client, and let's go rock. Okay, so that works, but it's not doing the locked in for some reason. So let's check this locked in portion. I just close that server and make sure that this is actually working. So that needs to be P2 went, and if this one should be working, that was what's confusing. Okay, so actually, so that one just need to be P2 went, game.p2 went. Let's try this server, and let's go client, and let's run it again, and go scissors, locked in, sweet. So that's actually working, and the game is pretty well finished. All we gotta do is add a menu screen, and then we're gonna be done. So now let's go scissors, scissors. That's not correct. We gotta fix that as well. Okay. I thought I had everything working, guys. I really thought so. Okay, so I do know the issue. It's pretty straightforward. So in main here, when we check the let's see here, the winners, where do we check winners? If it equals 1, equals negative 1. Okay, so game.winner needs brackets. Of course it does. So we need to add that. So obviously just some silly errors, guys. So server's running right now. Let's run these clients, see if everything is indeed working as it's supposed to be now. Okay, so let's try this. Paper, locked in, scissors. You lost, you won. Yay! Okay, everything's working. Okay, paper, tie game. Sweet. Okay, so you guys can obviously mess around with the timing, but you can see how this is working. So the only last thing to do now is watch this. If I disconnect, it disconnects both of them. So what we're going to want to do now, if that happens, is instead of just completely exiting the game, we're going to want to bring them to a menu screen where they can just click to reconnect. And this is actually really easy to do. So what we're going to do is we're just going to define another function. I'm going to call this menu_screen. Okay, and in here, all we're going to do is have a really basic while loop that just checks if you click something, and all it's going to do there is click the run that main function. So what we're going to do is going to say run equals true. We're going to say while run. Okay, and then in here, we're going to say for event in Pygame .event.get, and then obviously we're going to check if they click exit. So if event.type equals pygame.quit, then we will do is just do pygame.quit run equals false. Otherwise, if they click any key, so we'll say if event.type equals pygame dot, and we'll just say mouse button down. So we'll actually just get it, they'll click the mouse button. Then what we'll do is we'll simply say run equals false. And at the bottom of run equals false, what we're going to do is we're just going to call main. So all this is going to do, and we'll call menu_screen here. So we'll say while true, comma menu screen. Okay, and I'll go through this in a second. We're gonna say while true menu screen. Okay, so what we're gonna do is in menu screen, if they click something, we're gonna call the main function, which is simply going to do all of this stuff in here. And then if they exit out of the main function, so if you say like run equals false because they disconnected, it'll just rerun the menu screen, which means that they'll be prompted to reconnect to a new game. Awesome. What we'll do in here is we'll add a clock as well. So we'll say clock equals pygame dot time dot clock. Give it a tick. So clock dot tick 60. We'll just draw something in here. We don't need to use the redraw window function. We'll just do font equals pygame dot font dot sys font. In here we'll go Comic Sans. We'll go 60, and then we're just going to render some text. We'll say text equals font.render. In here, we'll simply say click to connect or click to play, exclamation point, 1, some nice red text. And we can just continually, actually, we can just window fill, so win.fill, and we'll just fill it with white 000, or what am I saying? Gray, actually, 128, 128. And we should just, where is win? Do I define it up here somewhere? Yes, I do. So that's sweet. Win's up there. So what we could do is just fill the window, run into this while loop, put some text on the screen. We may actually have to fill this every frame. Let's get rid of one of those brackets I created. So let's fill this every frame, actually. Okay, so we'll fill it. We will blit this font. So let's say win.blit text. And you know what? For right now, I don't want to deal. We'll just do it statically. We'll just do like 150. So it's nice at the top of the screen. Actually, let's go 100, 200. Okay, and go pygame.display.update, like that. Then if they click something, what should happen is it should break this loop. They should be brought to the main thing. And yeah, that should hopefully be working for us. So let's try this. Client, click to play. Okay, a little sketchy on the click to play, but let's see if we click to play. Okay, waiting for player. So this is what I wanted. So it says waiting for player. We're gonna wait for someone else to connect. Okay, boom, connected. Sweet. So now we're ready. So let's just run a game. Let's go rock, scissors. Now let's just see what happens if we click X. This one goes to the menu screen where it says click to play, and it can be, play against someone else, right? And that's exactly what we wanted. We may also want to add like a back button to go back, but I'll leave that to you guys. So guys, I'm going to leave the tutorial here. If you guys have any questions or run into any bugs or anything, please let me know. This is by no means like a full, complete game. There's still obviously a lot of things that could be added to this, and I might continue this series later, but I think for now, that's probably enough. I hope that you guys learned how to make an online game. I find this stuff really freaking cool and really interesting, how you can have like a ton of different clients connecting together. And with that being said, I'll see you guys in another video.